think I'm streaming now. Hi everybody, hold on. I was trying to not be as late as I usually am. Oh, you can't even hear me. Just the mic. Just bear with me for a second. Sarah is asking, any luck with the light? No luck with the light, but I will talk about it. Is mic on? Hello and welcome to, is it Thursday? Thursday afternoon coding train. You would think the fact that it's the summer, my teaching schedule is freed up, that I would be more consistent about the time and less late. Strangely enough, my life is just not working out that way. So I am apparently less consistent about the time and more late than usual. So I have to apologize for that. So, but the good thing is I'm here. I mean, I guess that's good. You're watching, so hopefully that's what you were hoping for. I have all my supplies, train whistle, water, warm beverage, sometimes caffeinated, sometimes not caffeinated. You can try to guess. Back to the lapel mic, which is here on my coding train branded hoodie. And of course, not of course, but I have, today I have a melon medley from an unnamed local shop that sells food items. And I paid $3.99 for this, which really bugs me. You know, I can never get myself to buy. You know, I go to the grocery store and they have the bin of sliced melon, and it's like $12 for like this large thing of sliced melon, which is approximately a single large melon entirely sliced. The single melon itself is usually like $4 or $5. I can't pay $6 or $7 to have my melon sliced. I have to slice it myself. Soft focus. It might be that the focus is messed up. There was some weird stuff going on in this room. So if the focus is bad, I will fix that. Let me know if the focus is weird. I will take a moment. Look at this. This is regular non-space melon. It is of the water variety, which goes well with Coding Train's main sponsor, H2O. Soothing. My stomach's a little bit upset today. Everything's off. Focus. No, but nobody's saying anything about the focus. Now, I also have the space melon, the mysterious, magical space melon. All right. All right, so this is going to be tricky, but let's see if we can figure this out. The good news is I didn't actually put the cloaking device on this yet. So this is approximately where I stand, about here. So if I focus on this right here, I should be able to fix that focus. So let's see if I can do that. Is that better? The problem is I can't see the output very easily. Oh, that looks better. Let's see how that is. Have I improved the focus? Of course, when I stand back here, I'm a little bit out of focus, but such is life. I'm hoping this has improved things. I'm going to pop out this chat. Oh, I don't even have the chat here. Oh. Okay, hold on, everybody. Pop out. I'm sorry that I really should get ready before I start. But today it just didn't happen. All right, now, oops, let me go back to here. Let me get the chat on my monitor. I have to do that. If I go to look at the live stream, I'm live right now. I go to that page. I see myself in the past. And then pop out chat. So now I can see the chat. All right, Burger Bob in the chat, I just pulled up the chat saying 20 seconds slow mode is too much. Please make it 10 seconds. I have no issue with doing that whatsoever. Let me see if I can adjust that easily. Unless the chat is presenting a problem, I'm happy to decrease the slow mode. I'm just curious, if anybody's a YouTube sponsor, does the slow mode apply to you or no? Maybe this is under advanced settings. Enable slow mode, limit chat posts to every 10 seconds per person. Okay, let's try that. All right, so I switched it to 10 seconds. Let's see how that goes. All right, let me move this water over here. Now here's the thing. One of the reasons why I'm late today, I was actually early. Not really. I was here at 1 o'clock to give myself a whole hour. You would have thought that maybe I would use that time to try to see if I could fix the whole thing with the camera shutting off. But of course I did not. That would be much too practical and useful and logical for me. So what I have done instead, yes, it applies to sponsors. Okay. No, who knows? I don't know what this means. So, I have this light. Oh, wait, can I turn this off? Yeah. This is a Philips Hue light, 600 lumens. I have it clipped right here to my table. Oh, welcome new sponsor, Meyer Shah. See, this is the thing. I was so excited. I almost want to tell you Meyer to unsponsor, maybe sponsor again later, because I also have over here this thing, which is a Philips Hue bridge. This is the thing that connects to the internet and controls the light. Oh, I got a little dizzy for a second there. It's extra warm in here, and anyway, okay, I'm fine. I'm just not sleeping well this week. All right, so what was I saying about this? This, I would connect to the internet. It would control the light. Then I could use an app on the phone, or I could write like a node program, all sorts of ways I could control the light in this room. And in fact, I could use IFTTT, which is if, then, this, that. I actually have no idea what that stands for. Something like that. I could use that to every time somebody sponsors to blink the lights, and possibly I could do something else, like if you're in the Slack channel and you need to alert me to a horrible bug in the code or the camera shutting off, I could set up some like sort of Slack bot messaging system to blink the lights. But if this, then that. Okay, that makes sense. If this, then that. Thank you, Chris Purgeon. The problem is, I'm sorry, I'm reading this Slack channel at the same time. Simon, I have seen your Barnsley's Fern message. Thank you. I'm kind of right now, I'm staying away from the matrix graphics stuff with TensorFlow.js, although I would like to return to that. But this is blocked on the NYU network. So I haven't figured out, I was trying different ways of like setting up my own network or like getting a network from like the laptop to give a network, but none of that was working. So I have to give up. Now, here's the thing. I'm thinking about when, at least as an experiment, maybe I'm here till 4 o'clock, which is like an hour and 45 minutes from now, in this room streaming. I can get this to work downstairs on the 4th floor of this building in my office down there, because we have a special sandbox network that I can connect to things in different ways that the larger NYU network does not work for. I also was thinking of the reason getting some of these for my home. I don't know if I want people blinking my lights from the internet into my house. But so if after today, if it's like 4 and I'm kind of, things have gone all right, I might consider going downstairs and just live streaming from my laptop webcam just to test out the light thing, see if I can get that to work. Okay, Sondra Sorbay sent me a super chat. Did not see that. I see a sponsor. I don't see that, but I believe that it did happen. Yeah, so people, I don't want to belabor the whole sponsorship thing, but YouTube has a sponsorship feature. You click sponsor. you get an invitation to the Slack channel, and I'll mail you some stickers. I also have a Patreon, which is basically the same exact thing. You just give your money there instead of there, but you don't get all of the Patreon thing has some benefits that YouTube doesn't have, but YouTube has all the emoji integration with the chat stuff. All right, the Phillips Hue bridge, that is correct. I've never used one of these before. So what am I going to do today? What I really like to do, this is what I would like to do. Don't worry, I'm not going to do this, but this is what I would like to do. I would like to lie down on the floor and do some like meditation, breathing, and stretching exercises. I feel like I have not found the right, I have not found the groove. Stella does not have her groove back yet. But maybe it will happen today if I start doing some coding. All right, let's see if we can get the whiteboard camera going. Yeah, Meyer, it takes, I have to send the Slack invite, which is not too easy for me to do. Actually, I could actually do this during the live stream. I don't want to waste people's time too much. But the Slack invitations have to be done manually. There's no automatic process for that. So if you go to the community tab, there is a post there that's sponsors only, and there's a Google form. Put in your email address there, and then I'll send you a Slack invite. If anybody watching has the sort of power or authority to figure that out in a different way and invite new sponsors to Slack, we could make that happen. But I probably can't do that during the live stream. All right, there we go. All right. So I want to continue with TensorFlow.js today, and I want to focus on something called the Layers API. So let's see what I have so far. I'm going to go to this YouTube channel I heard of called The Coding Train. And I am going to go to Neural Networks and Machine Learning, Session 6, TensorFlow.js. And so this is what I have so far. You know what? I think this might be a t-shirt day. I think that this hoodie is it's extra warm in here. I don't know if it's the New York City weather or what, but I'm going to switch to t-shirt, and that's gonna make everything all right again. Oh, much better. You know what it is? I was rushing also, and I'm on the 9th floor now, and I was down on the 4th floor, and I had to go back and forth. I just took the stairs. You know, I ran a half marathon a few months ago. I'm doing okay, but somehow taking the stairs up and down a couple times, I think maybe doing that right before I live stream isn't the best idea. All right. Oh, you can see this is the light right here. See? Unfortunately, since it's not operable, I'm going to just put it down to the side. Ah, polynomial regression. We should do that. Right? I was going to go right into the Layers API, and then maybe do like XOR as a kind of hello, I don't want to use the word hello world, but as a kind of basic example to see how the parts of TensorFlow.js, the Layers API works. But I kind of like this idea of trying polynomial regression. Let's look where I last left off with the linear regression example and see how much that would take. Okay. TF linear regression. One of these days I want to do a live stream. I say this every time where I want to like update my workflow. Okay, so if we look at the code for this, linear regression example. So there's some interesting discussion going on in the Slack channel about, there is a IFTTT applet for triggering a light from a YouTube sponsorship. So that exists. Everything else I'd have to do custom, and I'd love to do some tutorials about how to do that. But that's why I thought I could just get that out of the box. But one thing that you have to have working in order for that to work out of the box is a working light. All right. Informal poll, let's see. So what would I have to change here? I would need some more variables, TF variables. The loss function could be the same. The predict function would be different. Oh, and graphing it would be different. So right here, I would write the code for a polynomial equation. So that would be like something like, let's do that. Oh, let's do that. Why not? Why not? That's going to be fun. Loads of good times for all. Let's go. Where's that? What's that playground? What's the TensorFlow playground? Because I wonder if that has a... Yeah, I mean, basically what I'm doing is something like this. What I want is like creating an example like this. Okay. So we are now, let me just change a few things. I don't know if this makes sense to be like a coding challenge part 2 of that. Let me just go. All right. Any important comments or feedback before I start? Okay. All right. Why is this better? All right. Oh, nope. All right, that's good. I don't need this. Looking at the chat. Just 1 second. I think I need to read some random numbers. It's been a while. That's gonna help. Random numbers and Melon. Those are the things. You know, I'm gonna look at my YouTube analytics after this, because this will be the point where the graph of the viewership goes like this. $31,000. 53,000. Oh, there's a seed in this one. 837. 17,813. The music ended. Here's the thing. I'm a person on the internet reading from a book of random numbers, eating melon, which nobody really likes, to be perfectly honest, even though I do. And people in the chat are talking about whether Vim is like the best editor ever or something like that. Come on, people, get with the program. Free yourself from these worries about your text editor. Here's the thing. I like the honeydew, I like the watermelon. This is cantaloupe. Cantaloupe really, you know, it's part of the medley. I'll eat it, but 13,810. 51,503. 55,000. I think I could actually read the whole book if I just had a melon, although there's probably a limit to how much melon one should eat before you, I don't know. Could cause some problems. 64,470. I'm gonna need to save some of this for later if I'm really gonna get to solving XOR with TensorFlow.js. 82,556, 22,697, 54,985, 64,852. You know, when I was in college, I took this like performance art / dance class, and it was taught by the founders of the dance troupe Polynomial. I don't know if anyone's ever heard of Polynomial. And I had to do a performance for it. And my performance involved a Ziploc bag full of rice, rubber banded to my face, and there was like a song, I Have Rice on My Face, that I made up that went along with that. So in a way, it all led till now. Oh, welcome. I can't believe people are sponsoring this nonsense. You are all lunatics. That's all I have to say to you. I know I am a lunatic, but I thought you were very sensible, all of you watching. Okay, that was a little malfunction. There's a little hole here where the liquid comes out, and if you don't have that aligned with your mouth perfectly, kind of, I gotta get a beard trim. Maybe, you know, so many things are wrong. No, the problem is the dance skills. Here's the good news. I'm having these back problems, so I just got an appointment for some physical therapy to strengthen core muscle stuff. But the good news is standing is kind of the most comfortable for me. So that's what I'm doing now. All right. Cracking myself up. Hello, I am in this video going to do something not advisable, because really I should be moving on and making some interesting, weird, creative projects that make use of machine learning in ways I could never possibly imagine. But I'm not ready for that yet. I'm still in the world of implementing kind of technical demonstrations and examples to understand how things work. I kind of, maybe I'm stuck in that place for a little too long, and you should break free of that place and leave here and go somewhere else. But if you want to stay, that's what we're going to do. So what I'm going to do in this video, you might recall that I recently did a coding challenge where I implemented linear regression. The idea of linear regression is to have a data set. In this case, my data set is a bunch of points that I'm clicking. I'm just sort of adding arbitrary data to a two-dimensional plane by clicking the mouse. But this could actually represent, the x-axis could represent, you know, if we think about baseball pitching, you know, the speed of a pitch. And this could represent the amount of time it takes to get to home plate, although that would be inverse. Anyway, you get the point. The axes could represent data. So the idea with linear regression is, oh, can we fit a line that, can we make a line that fits that data? And the formula for line is y equals mx plus b. So the variables of our system are m and b, and we need to adjust those variables. And we're going to create a loss function that we try to minimize to blah, 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 blah. That's all in the previous video. So I thought, well, we're here. Why not just see if we can make a curve to fit that data? That's otherwise known as polynomial regression. So what do I mean by polynomial regression? It would be good if I had a marker. This is definitely not the right marker. I should mention that I'm really partial to berries, like blueberries. Blueberries I love. They just have, they're like much more acidic, so the melon is more soothing. Where is my marker gone now? Ah, you know the other thing? I purchased a ukulele, and in the last week I've been teaching myself to play the ukulele, but I don't have it with me. So stay tuned for, by the way, great YouTube videos for learning the ukulele. There's a woman, I forgot her name already, I think she's from Hawaii, and she does videos on how to play the ukulele. They were great. Christina, maybe? I'll have to look that up. Let's just see if this pen will work. Ah, this works fine. I don't know what's wrong with me. Oh, I didn't forget the cloth. But look, here's an old paper towel, so at least I'm reusing paper towels. All right. Okay, I got the marker. So the formula for a polynomial equation might look something like this. Y equals ax squared plus bx plus c. So in this case, this is a polynomial equation of order, do you say that, 2? But I could also have ax cubed plus bx squared plus cx plus d. But let's just go with this right now. So what does it mean? Actually, we should do one with, anyway, let's see. We're gonna see how this goes. I'm gonna get somewhere. So the point is now, really, I've already done this already. I can keep the same loss function. I can keep the same data set, the same optimizer, the predict function. The only thing that's different is I have 3 variables now instead of 2. And when I write the predict function, I'm taking the x values, instead of plugging them into this form of a line, I'm plugging them in the form of this polynomial equation. Let's go get started on that. Oh, you know what I'm gonna have to do? The way I draw the line was so simple because I only need 2 points to draw a line, but to draw like a curve, that's gonna require quite a bit more. All right, let's see what we can do. No, the melon. Do you know how expensive things are in New York City? First of all, Yellow Nova crew, thank you very much. But berries. One of the reasons why I got the melon, this melon at the unnamed local food shoppy nearby, this was $3.99. The berries, $4.99. $5 for berries that fit in here. I don't even think maybe they're organic, but I don't even think they're necessarily organic. Trader Joe's, that's the best place to get at least so I can find in New York City, to get the lowest price organic berries. Let me just check. I can start a new channel. I'm gonna start a new fruit. I should totally do a new reviewing fruit, like unboxing fruit. Let me just practice that for a second. Then what do? I talk about it. It's juicy, kind of sweet. It's a little weird tasting. I feel like it's probably been sitting. It was like cut and refrigerated. It's probably like a day old. Pretty good. Pretty good. All right. Linear, quadratic, cubic. Simon, thank you. You're always so helpful. Now people are just like giving me money for berries. I'm going to go get some berries this evening. Thank you, everybody. Oops. Why did this go off? Uh-oh, I lost the whiteboard camera. No, there it is. So I want to, let me just do some quick hygiene here. Polynomial function. Quadratic, cubic, yeah. No, let's go to, here we go. Degree 3, that's what I was looking for. Okay. This is for the fruit channel, get some organics. The coding fruit. This is definitely like the coding. This might as well, the fruity coder. I don't know. That works for this channel as well. The ratio of time I'm talking about fruit to time I'm actually talking about code right now is about 1 to 1. Looking up on Wikipedia, and thanks to Simon who's watching this live in the chat, I've now reminded myself that the number here is referred to degree. So this is a polynomial equation of degree 2, also known as quadratic. 3 would be cubic, so on and so forth. And linear is really, I mean, it's not a polynomial equation, but it's a linear equation, but it's of degree 1. And if you go and take a look at Wikipedia, you'll see like, okay, well, this is what it's going to look like if it's of degree 3. Then the degree kind of maps to how many hills and valleys you have. We'll see that. We're going to experiment with this. We're going to do some fun stuff. I mean, if you think polynomial regression is fun stuff. Okay, so now back to the code. So looking at what I had before, I'm going to just change this to now A, B, and C. And I'm going to have 3 variables, A, B, and C, instead of M, and B. Then, so now this, the predict function. So what do I need to do? I need to take A multiplied by x squared plus B multiplied by x plus C. So how would I write that with TensorFlow.js? I'm writing y equals ax squared plus bx plus c. So this would be constant y's equals x's square multiplied by a, adding x's multiplied by b, add c? What's the chance this is right? X squared times a plus bx plus c. I mean, it looks kind of right to me. I'm going to wait for the chat to tell me whether they think I made an error. Hills and valleys. It is how many times it crosses the x-axis. That's a much better way of putting it. Thanks, Rostel. Can I go back and restate this? I need to declare C as a variable. I'm pretty sure I did. They're all declared as variables. Yeah, all right, I gotta, all right. People in the chat are, I'm so informal about my math. By informal, I mean incorrect. Let's come back. Let's redo that explanation because I don't want to, hills and valleys, you're absolutely right. It's the number of times it crosses the x-axis. But you know, it's got to go up and down to do that. It's got to cross. But that's, let me go back to, the live viewers, you're going to have to bear with me today. I'm going to go back to explaining that again. I won't be able to live with myself if the live chat, I mean the comments when the video gets published. Okay, so all right, so I think this is going to be right, Mathieu. Oh, but let me undo all my code stuff. Whoa, oh boy, Adam Editor really is good at remembering. Undo past when I closed. Okay. All right, good. I think we're good. Let me just check here. Okay. Okay. If we come here and look at the Wikipedia page, you can see here this is a graph of a polynomial function of degree 3, meaning ax cubic. And notice, if we look at this, how many times does the graph cross the x-axis? 3 times. Of degree 1, how many times do we cross that x-axis? A line? Just once. So squared, twice. All right, so now I think we're ready to go and try to make some edits to our code. So the main thing we need to do, right, is change m and b to a, b, and c. M and b to a, b, and c. So I am going to change this to a, b, and c. Then here, I'm going to make this a, b, and c. And then just about everything else can remain the same. Of course, there's a really, really important, there's two other things that I have to change. One is this. This is me writing the TensorFlow.js code for y equals mx plus b. Now what I need to do is change that to y equals ax, where's that little hat, squared plus bx plus c. So this should be, let's see if I can figure this out, constant y's equals x's square, so that's the x's squared, multiplied by a, adding, and then what I want to add to it is b times x. So I have to add x's multiplied by b, and then I also want to add c. So I think this is right. ax squared plus bx plus c. X is squared multiplied by a plus x is multiplied by b plus c. I don't know. Let's see. Maybe this is right. Maybe this is wrong. But now I'm going to get rid of this. And interestingly enough, in a weird sort of way, I don't actually need to change anything else. Well, I do. So here's the main thing. I mean, I could run this right now just to sort of see if I have any errors. Now, weirdly, first of all, I think it's actually just running the old code. Ooh, what's this print line that I don't need? I don't need that. Oh, yeah. Oh, so I'm having some memory issues now. But OK, we're going to figure that stuff out later. Save. It's doing something weird. Now, interestingly enough, it's working. I'm kind of surprised by this. Oh, it's working. Of course it's working. It's just, but I'm drawing a line. The caret. Caret. It's not the hat. Okay, okay. K. Weekman, am I messing up? Did I miss something important? So it's doing something, but who knows what it's doing. The problem is here, I have this code here to draw a line between x1, x2, y1, between x1, y1, x2, y2. But now, instead of just using 2 points to draw a line, if I'm going to draw something that is a polynomial equation, a curve, I need to sample a lot of x points and get a bunch of y points and connect those with begin shape, end shape, and vertex. So let's see if I can put that in here. So what I want to do here, let's think about this. Line x. Ah, interesting. So I'm going to say, call this curve x. I'm going to make it an empty array. I'm going to say for let I equals 0, I is less than, let's do, let's say x equals 0, x is less than 1, x plus equal 0.1. So I'm just going to sample 10 points just for right now. Then what I'm going to do is I'm going to say curve x dot push x. And I'm sure there's a fill map quick way that I could do this, but let's just look at it. So I'm putting a bunch of points. 0, 0.1, 0.2, 0.3, 0.4, 0.5. Now, I need to get all the y's. I'm still going to use curve y. I'm still going to use data sync. And then now, I'm going to say for let I equal 0, I is less than curve x dot length, I plus plus, and I need to say, before I start this, I'm going to say begin shape, then I'm going to say end shape, and then I need to get just an x1 and a y1. X1 is curve x, I'm mapping curve x, index I, and y1 is mapping curve y, index I. And then let's put the stroke weight here, and then I'm going to say vertex x1, y1. So before I was just calculating 2 points, an x1, y1, x2, y2. Now I have a whole bunch of x's and a whole bunch of y's, and I need to set them all as vertices and then connect them with a line. Let's see what happens here. Whoa, interesting. So first of all, something weird is happening. It's getting a fill, which I don't want. So I want to say no fill. So this is kind of doing what I'm expecting, right? Doing what I expected. That one in the middle is really throwing it off. Let's see if I can actually try to draw a curve. Oh. So now I'm being told in the chat, degree equals the number of crossing points explanation is a bad explanation. Uh-oh, somebody's knocking at the door. I wonder if I'm being too loud. Hey.
Do you just do any post scan for the Wi-Fi?
What?
Do you just perform any post scan for Wi-Fi?
Oh, I did, yes.
Okay, because people, I think IT is saying you are
Oh.
you're a hacker or just try to.
I was trying to see if I could find the.
So let me report to them because they maybe will disable your.
Okay.
address.
Okay. Thank you.
Maybe you just try to find.
Yes. Yes. That was me.
Okay, got it.
Oh, look. While I went to answer the door, it took a while. It learned it. First of all, so if you're wondering what that was, remember how I was talking about my, I've been reported to NYU Internet Services. Where is that thing? Where is my Phillips Bridge? Where did I put it? It's my prop that I need right now. Oh boy, that was really loud for you, wasn't it? Where did I put that? The lamp is there. Yeah, if everybody was wondering if this really is live or not, I guess now you know the answer to that question. I can't find where that thing is. Anyway, I was trying to find on the network to see if that thing was on the network. So I just did like a port scan of like the whole network, which apparently you're not supposed to do. So unfortunately also I did it from the computer that's live streaming. So if the live stream suddenly goes down, it's because I got shut down. Hopefully, I should have muted my microphone. Okay. All right. The crossing point explanation is wrong because a polynomial function can have no solutions. So it's the number of real solutions. How many complex solutions equals the degree? I should never try to do any math. Let's read what it says here. constant, linear, quadratic, cubic, quartic, zero polynomial. Okay, the commutative law, blah, blah, blah. Real polynomial is a polynomial with real coefficients. And a complex polynomial is a polynomial with complex coefficients. The argument of the polynomial is not as restricted. S-plane, blah, 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 blah. Degree is the maximum number of real roots. Okay. Okay, max. All right, Mathieu, you're going to have to work your magic here. So that wasn't exactly right. Wait, let's see, how am I going to edit this in? I guess I could do my green screen thing. Concavity, yeah. That's what I was kind of thinking of. All right. So I know I did just say that the degree maps to the number of times it crosses the x-axis. You can think of the sort of like the number of actual real solutions there are to the equation, and it's really just the max. There could be no solutions to a particular polynomial equation with certain values for a, b, and c. So so it's really I'm getting in the weeds here because this is not my forte, and I'm always messing this up. But you know, technically, the degree maps to the maximum number of real solutions to the particular polynomial equation. And now I'm going to go on. Yes? No? Can that be edited together and can I not be flamed from the chat? I could just go all the way back again. Oh. This is one of those live streams where I get nothing done. All right, let's move on. Wow, people are really far behind in time, so that's why no one's answering my questions. All right. Right. Always has that many complex solutions. Oh, that's interesting to note. Oh, it's not relevant for this video. Yes. All right, I'm gonna fundamental theorem of algebra. It certainly is. All right, so I'm gonna keep going. Okay, so now we've seen here that this actually does. Oh, all right. Let me run this. Sorry, I had a little interruption there, so there was a strange edit, but I'm gonna now click with a bunch of points. And let's see what happens over time. So give it a little time here. I'm going to let the time speed up. It's going to be one of those fast forward things, Mathieu. Oh, keep going, keep going. I'm so impatient. Right. All right, so you can see that it's starting to try to fit the curve to that data. Now, there's a couple things here. One is I could really play with the learning rate. It's still incrementally very, very slowly changing. Look at that. It's moving, but it's moving very, very, very slowly. So the learning rate is something I could play with. You can see that the way I'm drawing this is particularly jagged. So what I'm going to do also here is just go and like really increase the resolution of the number of points that I'm drawing. And let's go look for the learning rate. I have it at 0.5. Wow. So I'm going to leave it at 0.5. And I'm just going to hit refresh. And I could also make it something easier for it to fit to, which is just like this. And so over time, you can see that it is trying to fit this particular curve to this line. Now, let's make sure we've done our memory management job. I'm going to go back and console log the number of tensors. All right, so something went wrong here. I'm creating more tensors than I'm disposing. So we've got to go and look and see what I've done wrong there. So what new tensors did I add? The y's, this gets tidied. The y's are disposed. So let me do my debugging where let me comment this out. Let me see if it's in the drawing. Nope. Is it in the, oh, you know what? I started with an old version of my code. So this just never got tidied. So that really needed to be tidied. I'm looking for another error. Oh, missing a curly bracket. Nope, 76. And really, let's do it this way. All right, hold on. Let me go back. Oh, I'm using an old version of the code. For some reason, the code that I started with doesn't actually have this section tidied. So I'm going to say tf tidy. And then I'm going to make this into a function. So I need to put a curly bracket here, a closed curly bracket there, this there. OK, so now this should, right? I'm only using 7 tensors. I can put the drawing back in, and there we go. Now, what if I want to have it? Yes. OK, so this is actually a good point. We could use one thing that I wasn't thinking about, and the chat is suggesting, is that I am using stochastic gradient descent as my optimizer. But there are other options for other kinds of optimizers. Let's go look at the TensorFlow API and see what the documentation. Was I not the documentation and see? There's another good suggestion. There's another good suggestion. Oops. Sorry, everybody. So that's one suggestion. Another idea that someone in the chat has proposed, stochastic gradient descent. So tf.train SG is here, so we can see momentum, eta graph, which one I should try. Oh. Let's try that. Does anybody have a suggestion? Oh, craziness. Learning rate's probably way too high. Learning rate is way too high for this. Yes, yes, I agree, I agree. I'm looking at the chat. Still perhaps maybe too high. Oh, I forgot I have it at mouse drag now. So I want to take out the, I'm going to just put this back to mouse pressed. Interesting. Whoa, look at that. Oh, come on. You know, something else I don't love about what I've done is Adagrad and Atom work. Let's try using Atom. Oh yeah, that's what I was looking for. I don't know why I didn't see that. How do you pronounce these, by the way? Adagrad, Adadelta, Atom. Let's look at the paper. Oh, fun times. Let's try, by the way, I've just gone off the rails. I'm forgetting about this really being like I feel like I need to do this again if I'm going to do it as a video, perhaps. But yeah, this is working better. Buttery smooth learning. Use a picture of a pencil. All right. Adaptive, Atom, yeah. Right, all right. I know, I think this live stream was going better when I was just talking about Melon and reading random numbers. All right, I'm going to torture everybody because I think I'm going to actually just go and do this whole thing from the beginning again. And it's going to be much faster. Mathieu's not going to have to do any insane editing. There won't be somebody. I'm going to use the correct code, and I'm going to feel like today is a success. So all of you watching this live stream, I apologize to you. You can all revoke your sponsorships right now, but I've got to start over. So I'm looking down for TF linear regression, sketch.js. I want to make sure I'm actually starting with the correct code. So many things went wrong here. Okay. All right, everyone. Yeah, I should do more things to get banned from the NYU network. I should be so lucky as to get fired from NYU. Okay, we're going to travel back into time, you and me, together. You know, I have to say, doing these live streams is actually quite good for my back because I'm moving around a lot. We're going to erase this here. And this is now, I'm just going to blaze right through this. Okay. Let's cycle the camera. Hello, coding challenge, the last one, part 2 of the last one, something maybe, I don't know. This is actually my second attempt. I started this earlier today, and I'm now going to try it again. You shouldn't watch this video. Go do something else. But I'm making it because I want to make this video. I'm gonna feel like I did something today. So in the previous video, I did a demonstration of linear regression. with TensorFlow.js. And the idea of linear regression is I have some data set, right? My data set are a bunch, I'm making up a data set just by clicking points, but you can imagine the x-axis representing something and the y-axis representing something. And then I'm trying to fit a line. I want my line to fit to that data set. And I'm doing that by creating in TensorFlow.js these variables that represent the m and the b of the formula for a line, and then I create an optimizer, and I try to like figure out the loss, like, well, if I have a line there, what's all the differences between all the actual data points and where the line is, and minimize that, all that stuff that I did in the previous video if you watch that. But linear regression can only ever fit a line. So what if, for example, my data looked something like this? Well, you can see the best line it can figure out to fit that data is this line, which isn't really accurate. But I could see pretty easily, like, oh, I could create a polynomial function, probably a quadratic function, that is a curve that looks like this, that fits all those points. So this brings me to the topic of polynomial regression. That's what everybody wants to do with their lives. So what is a polynomial equation? Well, in some sense, this is a polynomial equation. It's of degree 1. I could also have a polynomial equation that's like a constant of degree 0, y equals 5. If I had one of degree 2, what I have is y equals ax squared plus bx plus c. Quadratic. Cubic would be y equals ax cubed plus bx squared plus c. Now, what do these values, what does this mean? So the degree has to do with the number of solutions, whether they're real solutions or complex solutions, and there are a bunch of solutions that'll cross that. That's all this math stuff, which is not my forte. I'll try to find a good resource for, you know, the fundamental theory of algebra or whatever that you could read about. But the point is, if I just want to now adjust my code to use a polynomial equation instead of a linear equation. All right, so that's not going to be too hard. There's actually very little I need to change in the code. So let's go back here, and let's go to the code, and let's look. So here's the thing. Now, I'm not going to do this, but really, what I want to, I'll mention this at the end. I have an exercise for you to do. If you make it all the way into this video, I've got an exercise for you to do, which would be totally fun. I mean, again, in the world where polynomial regression is fun. All right, so I had m and b as variables. Now I need a, b, and c. Okay, so now I need, instead of m and b, a, b, and c, a, b. You know, one thing I don't like about this, you know what, I'm going to fix something first that I never liked about this example, which is that my space, my two-dimensional space goes between 0 and 1. I think it'd be better just for the world if it went between -1 and 1. So let me look at everywhere where I map. I mean, it's really going to be the same. -1 and 1, -1 and 1. I'm probably going to miss something. -1 and 1, -1 and 1. Just think I should have like a Cartesian plane where 0, 0 is in the middle as my data space, just for what I'm doing here. So I think, and then this should be this. So let's look at this. Whoops. Okay, I missed something. Yes. No? Shoot. Shoot, I missed somewhere. Why did I decide to try to do this right now? Terrible idea. It was all working fine. Let me just look everywhere I have map. Between -1 and 1. -1 and 1, -1 and 1, -1 and 1, -1 and 1. Oh, I think I got everywhere. Oh, there's such an interesting discussion going on in the Slack channel. I totally want to, I'm happy to participate in this later, but this is about YouTubing and the like. Line 35. Ah! There's the mistake that you all saw. -1 and 1. There we go, okay. Okay, so we're back. My linear regression is working. Just to be really sure, I'll put a point here. Oh no, look at this. Why is it clicking down there? Oh, I have it backwards. 0 to height, 1 to -1. All right. We're really going to get this. There we go. Okay, there we go. All right, now everything's fine. I can now go to changing these to, sorry for that little digression, A, B, and C. A, B, C. Okay, then what's the other thing that I need to change? So clearly, the thing that I need to change is my predict function, wherever that is. There it is, right? So this is the formula, y equals mx plus b, expressed with TensorFlow.js. Now, I just need to express this formula also with TensorFlow.js. This, I feel confident I know how to do because I did it earlier today. Y equals ax caret, or I like to say hat, because I think it's a little hat. X squared plus bx plus c. So I'm going to say constant y's equals, so x's squared, right? X squared multiplied, and all the stuff in TensorFlow.js can be chained, the mathematical operation. So the x is squared multiplied by a, adding the x's multiplied by b, that's bx, and then finally adding c. So this, it takes some getting used to how to like put all this stuff together, and I could put it in multiple steps to make it more clear. But this is the kind of thing you want to, if you want to get into the low-level TensorFlow.js stuff, you want to practice. So now I can get rid of, I'm just going to get rid of this. This is the predict function. Now I have another really significant issue here. So I'm not going to, let me just run the code to make sure there's no syntax errors. But it's obviously not going to do anything that makes any sense because it is, this code down here is designed to just draw a line. By the way, you can see I was doing some diagramming here earlier. In other words, I'm picking this point and just drawing a line. But in order for me to draw a curve, I can't, I have to sample a lot of points along the x-axis. So I need to make a loop, and I'm now going between -1 and 1 to sample all these points. I need to say begin shape, vertex here, vertex here, vertex here, vertex here, vertex, vertex, blah, 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 end shape, and I'll see that line. So instead of having x1 and x2, I want an array of x values. And I'm going to call that, instead of line x, curve x. And that's going to be an array. And I am going to start x at -1, go all the way up to 1, say x plus equals, and let's use some increment like 0.05. And then I'm going to say curve x dot push x. So I'm just trying to make, let me just show you what I'm trying to do here. Console log curve x. And there's going to be all sorts of errors here, but let's see. You can see here that I'm just trying to make an array that has lots of x values, but between -1 all the way up to 1. So I can, now I need to get the y values that go with that so I can draw this curve, and I have the predict function does that. So predict curve x, get all those y's, then curve y is then, and again, maybe I shouldn't be using data sync here. That's kind of going to be an animation slowdown problem, but hopefully it'll be fine. Curve y is now the regular number, the floating point numbers, not the tensor anymore, version of the y's. Then I can get rid of that tensor. I'm done with it. And instead of drawing a line, what I'm going to do is say now, OK, now I just need to go through and look at all of the x points and say the x value is map curve x index I, which goes between -1 and 1 to 0 to width, and y map curve y between -1 to 0 to height, and then I want to say before this begin shape, no fill, stroke 255, stroke weight 4, 2, or whatever I had it, and then end shape. Oh, I need to actually set the vertex. Vertex x comma y. So let's see what happens here. Look at that. So this, by the way, is the random curve that the coefficients, and I should get rid of this console log. So what's interesting about this is that every time I refresh this, I'm going to get a new polynomial, a quadratic equation, because it's picking random A, B, and C. And you know what? I didn't pick random any negative numbers. So this would also probably make more sense for it to, right? Couldn't technically these be anywhere, like I should start between like -1 and 1. Does that make more sense? Right? Yes, that makes more sense. So you can see I'm getting all these random curves. That's what it's starting with. Now, when I click, you can see it's trying to approximate the curve. Whoa, weird. Huh, that looks exactly right, but backwards. Why? Because I made this mistake again. Height is flipped -1 to 1. Oh, no, not there. It's hard to keep track of these pixel mappings between height and 0. Let's run this one more time. There we go. You can see now it's taking a while. Now let me be more methodical about this. I'm going to click like a bunch like this. It's actually finding it quite nicely, but you can see look at that. It's quite lovely. Let me do it the other way. You know what's bothering me is that you can see how this is not getting all the way to the edge. It's because when I created those points, I really want to say less than or equal to. I want to get the last point in there as well. Oh, why did I do this? That's a little bad trick there. There we go. Let me draw these now. There we go. So you can see this is working. Hooray! So now we have polynomial regression. Now one thing I probably would want to do is this, now that I'm getting past just sort of like basic linear regression, the optizer that I'm using, if we look at the TensorFlow code, is train.sgd, stochastic gradient descent. Let's just try for a second. Let's look at the TensorFlow.js API. And I'm actually already here because I was looking at this earlier. You can see there's actually different optimizers that we could try. A well-known one, Adam, the ADA here being for adaptive, I believe, like ada delta. But if I look at this, we can see, oh, this constructs an Adam optimizer that uses the Adam algorithm. I could click on this link here, and I could find this whole paper that explains it beyond the scope of what I'm doing right now. But just out of curiosity, all I would need to do if like, oh, maybe stochastic gradient descent isn't the best algorithm for fitting this curve. Let's just change this to Adam. And I kind of have a feeling that this learning rate being so high is going to not work for it. But let's leave it. So warning, it might flicker quite a bit. Let's just see what happens with like a very high learning rate. Yeah, you can see, look at it like, whoa, that is really fun. Actually, I kind of like it with the high learning rate because look how quickly, but you can see it's kind of like bouncing around. It's because it's high learning rate, it's going to overshoot the optimal spot. So let's just make that 0.1. And let's also, I think it would be fun to change this to mouse dragged. Although I'm worried I'm going to add so many points that it's going to really slow down. Yeah. Oh, while I'm adding the points, that's interesting. So while I'm adding the points, let's see, this is a little bit weird, but let adding points equals false. I'm just going to have, this is like a terrible idea, adding points equals true. Adding points equals false. This doesn't make any sense. Why would that be really slow while I'm adding the points? Because what I want to say is like if not adding, I was thinking I could like don't run the training if I'm not adding the points. Only run the training if I'm not adding the points. Yeah, that didn't really help. Why? What am I missing here? Sorry, the chat is fascinating. Oh, people are really complaining about my 1.01 fix. Now, why is it? I'm not sure. This section is so irrelevant to the regression tutorial. That is not worth. That was like a aside that I'm not gonna. Let me think about this. Right? While I'm adding the points, it's slow. And then it doesn't matter. It's happy to have a lot of points. Mouse drag gets called multiple times. On mouse, oh, right. So what if I did, yeah, right. I should do mouse pressed. Yeah, oh, I know what to do. All right, I'm kind of off in the weeds here a little bit, something that's irrelevant to this example, but I've been noticing that it's like really slow as I'm like drawing, and then as soon as I like let go, it's perfectly happy to like animate very quickly. I'm trying to figure out why this is. So one thing I'm going to try is I'm going to just add mouse pressed, and I'm going to say let adding, whoops, I'm going to create a new variable. Let adding points. I'm going to just actually call it let dragging equal false. And I'm going to say when mouse pressed, I'm going to say dragging equals true. And then I'm going to add mouse released and say dragging equals false. And then in draw, I'm going to do this now in draw. So this way I'm going to kind of like really keep everything in draw, and I'm going to say if dragging, then add points. And if you're adding points, maybe don't try minimizing the function. Just wait till you're done adding points to minimize the function. Let's see how that works. Yeah, there we go. So it's not happening in real time in the same way, but at least it's letting me add the points. So I'm intrigued why. I wonder if there's probably a different way to think about this, but I really love how that animation of watching it fit. Oh, that's really just very satisfying. So in any case, let's try, let me just try a smaller learning rate just because I'm curious. So you can see with a smaller learning rate, it's moving much more slowly. So the higher learning rate, it's going to get there much more quickly, but it's going to bounce. You could do something that's called annealing, I believe, of the learning rate, meaning start with a high learning rate, but lower it over time. You'd have to look at the TensorFlow.js API to see how that's done. But here's the thing, I really want to do this. I want to do this with a equation of degree 3, just because. So I'm going to do that manually. So I'm going to add a d here, and then I'm going to add a d here. And this is going to lead to my exercise for you. And then I'm going to say ax cubed plus bx squared plus cx plus d. So I want, is there a cube mathematical operation in TensorFlow.js? Square, operations. Operations, there's a square, pow I guess I could do. I'm just wondering if there's a tf.square. Is there a cube? No, so I probably want to do power. Where is that? It's funny how it's under, yeah. So I want to do this. Pow base exponent. So I would do x's pow 3 multiplied by a, adding x's squared multiplied by b, adding c, x's multiplied by c, and maybe I should start to do something where I put these on different lines. So let's do this. X's pow 3 multiplied, adding x's squared multiplied by b, adding x's multiplied by c, adding d. Right? Did I get this right? This is now of degree 3. X's to the power of 3 multiplied by a plus x's squared multiplied by b plus x's plus cx plus d. Okay, and then I think actually I'm good because everything else is the same. So let's go check this. Oop. Argument, exponent passed. Oh, must be a tensor, but got a number. Of course. So if I'm saying power 3, I need to say tf scalar 3. So everything's got to be a tensor. I can't just use numbers like I'm used to. So that's to be tf scalar.3. And let me put the learning rate back up higher. Let me put it back up to like 0.2. Wow, that is immensely satisfying. So now you can see, and by the way, if I happen to draw a line, it should still be really happy to sort of like fit a line there because it can just make those coefficients 0. Oh, this is great. Oh, I'm really glad I made this video, for myself at least. So here's the thing. Here's my exercise to you. How can you make this so that the degree of the polynomial is like something that can be interactive as well? So could I have a drop-down that allows me to try it with a degree 2, degree 3, degree 4, or maybe a slider? What other kinds of interactive features could I add to this? And how could I maybe like have the data set come into this in a more interesting way besides just kind of drawing with the mouse? So could you make, what kinds of things could you do with this? And I think there's some interesting visual possibilities. So I hope you enjoyed this video. I'm going to publish this code now as a coding challenge called, it's really part 2 of the linear regression now, polynomial regression. And I'll see you in future videos. I'm going to work on that. I'm going to look at that TensorFlow.js Layers API soon enough. OK, goodbye. Yeah, so Tobias in the chat is asking, why didn't x less than or equal? Let me address this. So this is really weird. But why did this not work? Why did this not work? Here's the thing. Floating point math on a computer is a weird thing. And I've encountered this in many videos and tutorials, but many, at least somewhere I cover this in an actual tutorial. But like, let's go to the JavaScript console for a second. And I really should let this, let me just shut this off. So let me show you something. Oh, it's being much too nice to me. Maybe it's like, so anyway, there's all sorts of weird rounding stuff that can happen. Floating point rounding errors is like a thing. Because the computer's not actually storing this number as you see it. It's storing a representation of this floating point number with a certain number of bits. And it has a limited number of bits. So it can often kind of like get off by 0.00001, which doesn't really matter if you're just doing like a simple graphic simulation, but if you're doing some like very highly specific math, that's why in certain programming languages and environments you'll find double, which is more memory for decimal numbers. You'll also have like kind of like specific math. Like I bet you TensorFlow deals with this stuff in a much more like lower level and accurate way, probably. 0.01 plus 0.02, I'm being told. No. In short, oh, yes. The dangers. What are the dangers? Oh, maybe I should try that. 0.0100. No, I don't know. I don't know how to get it to show up the... I don't know how to get it to show up. It seems to be working perfectly. There's nothing wrong at all. Let's Google that. Dangers of overfitting polynomial curves. All right, so maybe I'll mention this real quick. I forgot something important that I was told by the chat that I should mention, and I'm referring of the dangers of overfitting a polynomial equation. And that's what this being represented on. This is a Wikipedia page for overfitting, which is a term that you'll hear a lot in machine learning, meaning what is overfitting? So if my data set, if those points are my data set, a really fancy polynomial equation of some high degree is going to be able to draw something like really accurately connecting all those. But it doesn't actually have any real meaning as applied to the data. The data can have a lot of noise in it, and a line might actually be an appropriate way to make a prediction, even though it doesn't fit. It has like a higher loss than the polynomial. So, so this idea of generalization, you don't want your machine learning model to work so accurately with your sort of known data set that it cannot make good predictions with an unknown data set. And this is something that will come up more and more as I do more videos and tutorials with things. Here's the thing though, I kind of like this example that I made for the fact that it does something kind of interesting visually, in that it just like figures out how to make this polynomial function fit this arbitrary set of points. So I think for sort of like some kind of artistic output, there might be some value here, but yes, thinking about actual machine learning and how you want to make predictions is important. So that's why I'm here with this public service announcement. The more you know. The more you know theme music. Goodbye. Oh, there we go. CJ got something here. CJ, are you CJ Coding Garden? There we go. Woohoo! There is our floating point rounding error thingy. Was the sound all awful in that and it won't be usable? Yes, okay, CJ. Yes, CJ is great. Coding Garden with CJ. Guitar. I love that you use the guitar, CJ. Everyone should check out Coding Garden with CJ. I wish I watched more, but I've caught a few of the streams. All right. Ken Haley writes, only use higher order polynomials if you know there's a reason to do so, not just the data. Yes. Will you keep the beard? Since when have I ever not kept the beard? Thank you, Ken, for that clarification. All right. It's 3:40. I could go downstairs and live stream me playing with the Phillips lamp, or I could talk about the Layers API. I should probably talk about the Layers API since that's what I said I was going to do. Let me give me a minute here to figure out what I'm going to do next. I have one more piece of space melon. The curves array has the mistake. What mistake do I have? One more piece of space melon. I don't know how much longer I can do this with no. All right. Can I stop the infinite loop? What infinite loop? All right, I don't know what's going on. Let me just make sure NYU is not shutting me down. Ooh. Oh, I got another sponsor that I missed. Because I'm getting, so I know the Phillips Light thing will work because I'm getting email notifications. Thank you to Sripriya. Okay, I'm not seeing any emails from internet services here telling me to stop doing what I'm doing. Okay. All right. I think I can move on. Yes? Slack channel. Any more things to say? Let's, I think I'm going to erase this. I'm going to reuse my paper towel. Right? Yeah. That's probably what I should do, is always do everything twice. Where is the, yeah, I don't know why I can't find that Philips Hue light bridge. It's like completely, oh, there it is. This is the prop I was looking to show. Oh, you're over here. This is the prop I was looking to show. So that's what caused me to get banned from the NYU network. Okay. Oh, remember when I used different pen colors? Those were the days. I want to do the XOR. I want to do a video. I want to do a tutorial now about the Layers API and try to train a model to learn XOR. Other thing that I'm thinking about doing, at the TensorFlow, one of the TensorFlow videos was either at the Google I/O conference. I think it was at the I/O conference, not at the Dev Summit, but I can't remember which one. And it's part of the tf.js examples, did a classification example with Major League Baseball using like pitching data, and like sort of looked at the speed of the pitch and different things, and then classified it as I think as a fastball or curveball or slider. So I think that I would like to get to some more actual real data examples. And then I'm going to do the doodle classifier. I should do all these things. And then eventually ML5. All right. Okay. Let's see here. So now let's make some changes here. I'm just going to do some housekeeping here. Okay. It would be nice if I kind of knew the Layers API. Oh, look, there's a big thing of paper towels here. That's funny. Izumi asks, does YouTube create a video on demand once the live stream ends? Yes, it does. It sometimes takes a little while. And it actually, the way I have it set up is it automatically goes to unlisted. But this URL that you're at right now, it will be there. And then I make it listed once I've had a chance to work with Mathieu to like write the description and all that kind of stuff. All right, so layers. Okay. Just going to look at some examples that I was working on. I should really pin some repositories. So let me look at this. Oh yeah, I had all this extra stuff. Okay, right. Sequential. And then you add, you can create layers, create an optimizer, and you have to compile it. You can just set a loss function. And then, so that's pretty much, then I can just call predict. Okay. All right. What's TF model that's different than? The difference between TF model and TF sequential is that TF model is a more generic, supporting an arbitrary graph without cycles of layers. TF sequential is less generic and supports only a linear stack of errors. Oh, interesting. Oh, interesting. So I'm used to just using TF sequential. But I'm not going to worry about TF model right now. Yep. Input, what's this? All right. I haven't used that. And then these are the different kind of layers. And oops, just want to look at my example. Oh, I closed that. I just don't know any of this stuff off the top of my head. Units, input shape. So where, I want to look up, I just want to see what's in the API so I can, the things that I want to look at are TF sequential. I want to look at dense. I already have then, so this I need dense, input shape, config, okay. That I need. Oh, why do I keep closing my thing that I want? Things I want to cover are dense, sequential, compile, so I'm going to need sequential, compile. So that's under objects. Yep. Okay. Compile, add, so I need this. I think this is going to be enough. And then predict, I also want. Right, this should be a predict. Evaluate, predict, yep. Fit, we're going to get into also. Okay. Anyone who has experience with this stuff, is there anything super important about TF sequential versus TF model that I should make sure to cover? Okay. All right, I think I'm going to talk about the Layers API. And I think I want to use the toy neural network. Okay. Actually, just look at the library. Does this make sense to look at? To do. All right. All right, I'm not gonna, I will just. Okay. Yeah, dense layers are what I used, yeah. Yeah, okay. Okay. Hello, welcome to another TensorFlow.js tutorial. Now, I'm very excited about this one. I'm generally excited about a lot of things, but in this tutorial, everything that I've done so far has just used tensors, operations to kind of create lists and matrices of numbers and multiply them and add them and optimize loss functions, that kind of stuff. Now, and I could keep going, and there's a lot that I could do with just that alone. But TensorFlow.js, I talked about this in the first video, it has the sort of core API, which has the tensors in it, the operations, and it's what I use to do a linear regression and a polynomial regression demonstration. It also has something called the Layers API. And the Layers API might look familiar to you if you've ever used something called Keras, because these are really Keras layers. Keras is a machine learning library that is a higher level that allows you to sort of create these machine learning models, and underneath the hood, a lower level code like TensorFlow will be running. So when TensorFlow.js was created, it was created with both the sort of lower level stuff and the slightly higher level stuff. And I also am working on, with a lot of collaborators here at NYU ITP, an even higher level library that's built on top of the Layers API called ML5. And I'll be getting to that eventually. In this video, I just want to talk about what the Layers API is and its core features. And so the way that I'm going to do that is by looking at a sort of basic diagram of a neural network and how you would put together that neural network with the Layers API. And the kind of neural network that I'm going to diagram is the same exact one that I did in my very long tutorial series about writing a neural network all from scratch. So the point of this is you don't have to write it all from scratch. You can just architect it with the Layers API. But if you want to like get everything you possibly could ever get, you could go back and look at some of those videos if you want. So what is so I'm going to look at a simple, well, it's not simple, but a basic feed-forward multi-layered perceptron, and it's going to have just 2 layers. So, and it often looks like 3 layers because there's also the inputs. There's the inputs, the hidden, and the outputs. That's 3 things, but technically there's only 2 layers, and you'll see why. So let's consider that we have this neural network. It's going to have inputs. Let's say that it has, I don't know, 2 inputs. Then it has a hidden layer. How many nodes are in the hidden layer? I don't know. Let's say 4. Then it has an output layer. How many outputs are there? I don't know, maybe we're doing some kind of classification task and there's 3 possibilities. It's either a cat, a dog, or a turtle. So there would be 3 outputs. I started diagramming. The scenario that I'm going to do in the next video, maybe as a coding challenge, is I'm going to solve again the XOR problem. I really would like to get to some real world applicable problems, but I'm still here in the weeds of just like, I want to see how things work and use kind of trivial kind of known problems just to see if I can get the solution that I know I'm supposed to get. Okay, so if this is my diagram, if you've never seen a neural network before, again, you could go back and look at some of my other videos, but the idea is there's some data, we might call this like x0 or an x1, and that data, each of those inputs gets sent to each hidden node. There are weights here. The inputs get multiplied by the weights, added together, and then passed through an activation function, and then gets sent out to each of the outputs. And so that happens at each one of these. It's very hard to draw this. I'm sure I missed the connection, which, by the way, is something called dropout. So I've done dropout correctly if I forgot to draw something, but I'll get to that in another video. So then we have the outputs, and those are, again, the weighted sum of all of the outputs of the hidden layer, the hidden nodes, comes into the outputs, passed through an activation function, and we see the result. So the idea here is maybe that I have an image with just 2 pixels in it, and two pixels come in. They get multiplied by all these weights, activated for the activation function, sent to the outputs, and then I get some values that tell me the probability of those 2 pixels were a cat, dog, or a turtle. That would be an image classification task. So how do I use the Layers API to create a neural network with this exact architecture? So the first thing that I need to do is create something called tf sequential. So tf sequential, and let's go look at that in the API docs. And I'm right here already. TF sequential is creates a sequential model, is any model where the outputs of one layer are the inputs to the next layer. That's what it says right there. And guess what? And I know, I'm sorry that I've kind of gone a little bit too high in my writing, but the outputs of one layer are the inputs to the next layer. The inputs go into the hidden, the outputs of the hidden go out. So that's exactly what I want. I should say there is also something in the Layers API called TF model, which I'll click on here. And the key difference is that TF model is more generic, so there's kind of more possibilities there. But if I really just want a simple, basic feed-forward neural network where the data flows in one direction between layers, TF sequential will work. So if I'm writing some code, I would say const model equals tf.sequential. Ta-da! So there we go. I'm done. Well, not exactly. So that's just creating a sort of empty. So all I've done is created this kind of empty architecture. So what I need to do now, and by the way, this is what makes working with something like the Layers API really powerful. If you watched my tutorials where I did the whole neural network from scratch, it was so much easier just to have one layer, and I never kind of got to like multiple layers because I have to rewrite the code and think about the layers and how they're connected and have a loop and all this layer object. Well, guess what? The Layers API has this for you. So I can actually just say TF now, add layer. So I can actually I can create a layer. So the kind of layer that I want to create is known as dense. So what is a dense layer? A dense layer is the terminology for a fully connected layer, meaning that every node in that layer is fully connected to every node from the previous layer. And that's exactly what I have here. These are dense layers. All of the connections are there. So, and you'll see there's like other kinds of layers. There's a convolutional layer that I'll use at some point when I talk about convolutional neural networks. Other things too, but dense is where we want to get started. So let's come back and look at now the API docs for dense. And I think I opened that up here. Yes, tf layers, sorry, it's tf.layers.dense. So I need to say const, and I'm going to call this hidden, equals tf layers.dense. Const output equals tf layers.dense. So I'm missing a lot of, but this is the idea. So like I will have a model which is a sequential, and then I have a hidden layer and an output layer. And we'll talk about the inputs in a second. And then I would just say model.add layer hidden, model.add layer output. And I think I'd like to say outputs. Well, I guess it's the output layer. Whatever, let's just say output. So this is the idea. This is how, in theory, simple it is to build your own model using the Layers API. Now what's missing here? Like I could, weirdly enough, let's just like run this code and see if we get any errors. So it cannot read property name of undefined. So, okay, so who knows what that error is? But the thing that I'm really missing here is I need to be more specific. Like I need to say when I make a layer, what is the shape of that layer? In other words, how many nodes are there? What's the shape of the inputs? How is it connected? What activation function am I using? Those types of things. So those are, if we look at the API docs, the configuration of the layer. So, so I need to actually configure the model itself and configure each layer. So let's go look at that and see if we can figure that out. So let's go look again at tf sequential. You know, actually, I think we're going to be fine right now with, there's an optional, this question mark means optional. There's an optional parameter config. What I am going to skip that right now. Yeah, it could be, I could actually create it with a bunch of layers already and a name, but I'm going to skip that. What's more important here is the, the config object for the dense layers, which is required. So that's why I'm getting an error. This is required. So I need to specify some configuration options. And this should be listed for me here. Units, activation, use bias, kernel initializer, blah, 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 blah. And sorry for these markers here. So let's start adding some then. And what that means is I need to create an object. I'm going to call it config. I could call it. And here is where I'm going to set up the configuration of this hidden layer. So what I'm going to do here is let's look at what some of these are. So units. So what I want is what's the unit? So in this case, I want to have the hidden layer has 4 units. And so I'm going to say units 4. Maybe I want to specify the activation function. So what activation function you use is a fascinating topic that you could go down many rabbit holes for different scenarios. But and I'm just going to put sigmoid in there as kind of for historical reasons. And that's also the activation function I used in my toy neural network JavaScript library. But eventually, as I start to build out examples, I'm going to be taking out that sigmoid and using other ones. So I'm going to say sigmoid. And I'm going to put config here. And maybe I'll just say config 1 or config hidden. Again, I could put the object itself directly in here. There's lots of ways you could probably write this code in a much shorter way. I'm trying to write it in as long a way as possible to be most clear. So let's do that. And let's do config output. And what did I say? How many outputs do I have? 3. And I'll also use sigmoid. So I'm going to say 3. And I'm going to say, now I'm going to say config output. Okay, so things are going pretty well now. I'm going to hit refresh here. Config is not defined, sketch.js line 7. Oh, right, config hidden. Ooh, oh, interesting. Time out for a second. I just need to take a pause for a second. I need some water. How's this going so far? Is this like kind of helping people? Clear? Interesting? Useful? Too long-winded? I guess it's not add layer. All right. Let me just take a peek once again at my example. Oh, input shape. That's what I'm forgetting. Of course. That's what I'm forgetting. Okay. All right. Amusingly, I got this weird error message which makes no sense at all. It actually makes sense, but it's because I've got the P5 library involved here, and P5 actually has a function called model. So let me just, right now P5 is irrelevant for this discussion, so I'm just going to comment out the P5 library and then hit refresh here. Now, add layer is not a function, so I must have imagined that this is how you add a layer to the model. Let's actually go and look. And where would I find that out? Once again, if I go to, so here what I want to look at is, it's a little hard for me to find things. Oh, no, okay. I know what I want to look for, so I'm going to just search for it. I want to look for the tf sequential class. So tf.sequential, the function, creates an object that is a tf.sequential. So if I look at this, we now look that the function is just add. There's no add layer function, it's just add, which is a lot nicer, actually. So this is meant to just be add, and this is meant to just be add. Okay, so now, and this is really bothering me that it's calling this polynomial regression. So I'm going to have to change this to Layers API explanation. There we go. Okay, uncaught error. The first layer in a sequential model must get an input shape or a batch input shape argument. All right, so what did I miss? This is what I was talking about. So the inputs are technically not a layer themselves. The inputs are, in a way, part of this hidden layer. They are the inputs to that hidden layer. The inputs to the outputs layer are the outputs of the hidden layer. So one of those properties that I have to specify is the input shape. Now, interestingly enough, it says I need an input shape or an input batch shape. And what's interesting about this is what is the difference? So here I can clearly say that the input shape is 2. There are 2 inputs. It's just, actually it's 1. Well, no. It's 2. It's an array with a number 2. It's confusing. This is what it is. It's one-dimensional. It's a one-dimensional array with 2 spots in it. But someday there might come a time where I have a data set that is just each record of that data set is 2 numbers, but I want to send in 100 of them at once. That's known as a batch. So the shape might be something like 2, 100. But this is not super relevant for right now. This is what I need to specify. So if we come back to the code, I should here, going back to sketch.js, what I need to specify here is input shape 2. And again, I made this up. Like I'm just saying, my model architecture has 2. So now I should be able to, no errors. So I've created that model, and I can even take a look at it here. There it is. You know, all this stuff, input layers. We can see all sorts of stuff here. Now, there's not much there actually because I've forgotten a really crucial step. But let me keep going. There's some more stuff to discuss. So the input shape is 2. What's the thing? How come I don't need to specify an input shape here? You would think that I might. Hold on, I'm just doing some camera cycling. After all, I had to say that there were 2 inputs to hidden. Why don't I have to say that there's 4 inputs to outputs? Well, the reason why I don't is because TensorFlow.js, the Layers API, can infer the input shape of the outputs layer because it has to be the number of units in that hidden layer. And by the way, it's, actually naming these things like hidden and output is almost less relevant now. It's really kind of like layer 1, layer 2, that sort of thing. So, so I could put input shape here, and I would put 4. Now let's just see if I have any errors. Everything's fine. Now what if I put like 8 here? Am I going to get an error? Now, interestingly enough, I didn't get an error. That's weird. Now, why didn't I get an error? Well, maybe it should give me an error. I don't think so, though. I should get an error, though. I'm missing a crucial step here. I actually have just set up the idea of this sequential model. I have the model object, I have the hidden layer, I have the output layer, I've added them both in, but I actually haven't like plugged all the pieces into each other yet and finished it off. That has to come as a separate, it's not building up the model as you're creating it or configuring it. It's at the Layers API asks you to configure it and then call a function called compile. So I'm making list of, and this by the way was in tf.layers.dense, but another really important function here, compile, is part of a sequential object. Add was the other one, if I'm sort of keeping track of the things that I'm looking at. So add I looked at, now I also need compile. So let's go take a look at that. So if I go to the documentation, here we can see there's add, evaluate, there's a bunch of things. I'm looking for compile. Wait, maybe compile is not part of TF sequential. Oh, it is. It's just listed as part of TF model because TF sequential is based off of TF model. So this is what I'm looking for. This is me needing to compile the model. Now I need to compile it with an optimizer and a loss function. Aha! So if you watched my linear regression with TensorFlow.js videos, you might remember that I had to create something called an optimizer. And the optimizer's job was to minimize a loss function. So the same thing, the idea, I just had y equals mx plus b. Now I have a more complex architecture to learn about a data set. So what I want to do with that architecture is the same, though. I want to feed it a lot of known data and have it optimize all of the weights of all these connections to fit, and this could be fit that data. So I need to specify those things. So how do I do that? So first, I'm going to make, I'm going to call this just like config, and I'm going to say optimizer is, and so some options here, a string or a TF train optimizer. So I think what I actually want to create my own optimizer, and I'm going to go do that by saying constant optimizer equals tf.train.sgd 0.1. So if you remember, this is a way, this you might not have seen before if you're watching this video for the first time, but this is exactly the same code that I had in my linear regression example. I'm creating an optimizer from tf.train. The optimizer uses stochastic gradient descent, and the learning rate is 0.1. So this will be the optimizer. So I'm going to say SGD optimizer, like that. Then what else do I need? A loss function. So the loss function can be, I could probably define my own loss function, or I can use a string. So I'm not seeing here the options for the loss function strings, but let's see. Loss function, like basically what I want to add here is like mean squared error or something as my loss function. I don't think that's right. But let's just see now if what I would do is say model.compile config. So now, right? Let's review. Create the TF sequential object. Configure some layers. Add them to that model. Then configure basically make an optimizer and a loss function, define those, and then compile the model with those. So I'm sure there's going to be lots of errors here, and there's things that I've done incorrectly. So unknown loss, mean squared error. So let's figure out, how do I look that up? So let's see here, mean squared. Look, I found it in an example. So losses, let's look at this. I'm just looking for the list of them. But I'm gonna come back. I'm gonna find that and then come back and show it to you. But now that I see this is just lowercase m. So somewhere in the documentation, I want to find what the options I can put here are. Let's now hit refresh. Ooh, no errors. Interesting. So this is weird. I'm surprised. I don't know if this is a bug or not, but I'm surprised that I didn't get an error for this input shape here for the output. Maybe once I started feeding it data, I'd get an error. Maybe I never would. But I'm just going to hit refresh. So OK. So pause for a second. People are talking about the cameras in the chat. So I want to pause here to find the, to just look at my example that I made the other day. What else did I put in compile? No, I just had the optimizer and the loss. And then predict. I can do predict based on some x's, and I can do the training. So I can do fit. OK. So I probably want to add fit. So where do I find in the documentation the possible So my guess is that you can just use this any of these loss functions as a string, right? Where did I write dad? Oh, Simon is telling me I wrote dad. Where did I write dad? Compile. Oh, here. Yeah. I don't know why I did that. Okay, there we go. Fixed. Y input shape of 8 when we said 2. Oh. Yeah, no, it shouldn't have an input shape of 8. The correct input shape should be 4. So hopefully I didn't make that way too confusing. OK, so let me come back here. OK, just to be clear, the correct input shape here should be 4. The input shape of the next layer should match the number of outputs, the number of units in the previous layer. If you think of this as layer 1 and layer 2, but I don't actually have to include that because it can be inferred. So I just want to be clear. I was kind of experimenting to see if I could have it give me an error, but I haven't figured that out yet. OK, so I'm actually in good shape here. There's no errors here. So let me see, what can I do now? So the two things that I can do. Now I have created my model. I've created my model and I've compiled it. And by the way, I couldn't find in the documentation necessarily where there's a list of different loss functions I could put here. But my assumption is that these are a whole bunch of different loss functions. I could probably just use any of these as a string. So for example, if I want to use softmax cross entropy, oh yeah, that's one of my favorite loss functions. It's going to like, oh, unknown loss, softmax cross entropy. So maybe this... Nikhil, are you in the chat? Does anybody know? I got to pause for a second. I don't think it has to be 4. Why? Because you could add. It doesn't matter. So why? So somebody explain this to me. What am I? Why? Like, if I suddenly wanted, if in the case where I actually made like 6 the shape to here, is there just some extra random data that I would be required to add in here? I think you can click on loss on top to see all losses. So I'm going to, Matthew, I'm going to go all the way back to I'm going to try to explain where you can find the list of loss functions and that this input shape 8 thing was like very misleading. So where somebody was saying that I could click on losses at the top. I don't know where that is. Oh, here. Yeah. But it's not showing which ones are available as a string. So let's just try some of these other ones. Absolute difference. Yeah, weird. Because it definitely is happy with mean squared error. So let me look again. Any of these, like cosine distance? Oh, maybe you can't use those with this particular optimizer? No. All right. All right, so I'm not going to worry about that too much. Let me see, did anybody? So there's a difference. Jessido in the chat is asking, don't you actually have 3 times 4 equals 12 inputs? There's a big difference between the weights. The weight matrices have 4 times 3. But this is what the Layers API is keeping track of for you. I should mention that in the part. Just search the doc near mean squared. Mean square should be near. I think it should be possible. Maybe a bug. Maybe that's a bug that I found. So I'm just going to, like gloss over that, unfortunately. Object functions or names of object functions. Oh, so in other words, I think I found a bug. Oh, you know what though? I think there's a new version of it. So let me make sure I'm at least in the current version. Somebody fact check me on my version. What was it again? Shoot. Mean squared error. So let's try this. Whoops, sorry. Okay, it likes that. Yeah, so it's fine with, it's fine with the other loss functions, but not as a string. So I think that's a bug. Yeah, so interesting. That's really interesting. So I'm gonna, okay, so can anybody, so I'm gonna go back again. I'm gonna redo this part of the tutorial. From here, and I know how to like fake it now. We can maybe add this as a bug report. But what I want to clarify this. So here, and all right. I want to understand, is there a reason why you would ever do this, or should it give me an error? Before I move on, I need to feel confident in that. My understanding of it was this would just be a mistake. And you don't actually put the input shape here because you're going to infer it from the units. And if you put one there that's wrong, it's going to throw an error. I'm waiting for K. Weekman, maybe. You guys are all... Yeah, TensorFlow.js is brand new, so I'm not surprised that there's things like that. It's always really tricky when you work with, like, or even work with P5. You're like, oh, did I make a mistake, or is there a mistake in the library? It's very hard to figure that out. It helps when you're live streaming to an audience of lots of people who will help you. I know it won't give me an error. Yeah, it might mess with your network. Okay, I think I'm going to feel confident sort of in my thoughts here. Okay, I'm gonna go back. Sorry, Mathieu, for the editing complication, but hopefully this makes sense. Okay, I want to clarify something really important here because I kind of put this in here as like a demonstration of some goofiness I was trying to like figure out. But the input shape. So a couple things. Let me first mention something. Somebody in the chat just asked me, oh, isn't it 12? Because there's 4 here and there's 3 here, and 4 times 3 equals 12. Well, the number 12, and I know I just sort of wrote that up too high, the number 12 is an important one. There are 12 connections, meaning 12 weights. But this is now, we're in the place of using the Layers API. That is specified for us. We just need to say there are 4 here, there are 3 here. And we need to say there are 2 coming into here, and there are 4 going into there. So 2 is the input shape to here. 4 is the input shape to here. Now, I have this weird 8 in my code because I was like kind of messing around. Be like, well, what happens if you put like the quote unquote incorrect input shape? And so this really should, if I want my network to match what I'm drawing over there, this should be a 4, but I don't need it because it can be inferred by here. And I think what I'm going to do actually now to make this a little more readable is I think it's, as much as I wanted to try to write this in a long-winded way, I think I'm going to take the configuration and just put it right here inside the creation of this layer. And then I'm going to take this object. I don't need to name these objects and do this. I think this is actually easier to follow. So now you can see, I think this is easier to follow, right? There's, and so there's the model, there's the hidden layer, the output layer. I need to specify the input shape always of the first layer. And maybe what I want to do is actually say, add that hidden layer, then create the output. It doesn't really matter what order because I'm going to compile everything. So I have the, create that, let's review. Did I already do this? I might have, but I need to do it again. I need to create the sequential object. I need to make whatever layers I want, configure them, add them in, and then I need to compile it. And notice, compiling it, I need both an optimizer, which I created one, stochastic gradient descent. I could have used the addab one or any of the other ones. Again, what these are and what the formulas are, there's a lot. We could go down many different paths and rabbit holes for a lot of depth here, but I'm just kind of looking at the higher level point of view here. And then I need to compile it with a loss function. So mean squared error being one of them. And I actually, all of the loss functions are listed out here. This is where they are. So for example, so I can name it by the string, or I can actually just reference the function name directly, like this. So this should also not give me any errors. And you could see now that if I wanted to use like, oh, cosine distance, I heard that that's the loss function I should be using. I could put that in here, and I could also hit refresh again, and now I'm using cosine distance. So again, what the different loss functions are, why you should use one versus the other. Hopefully I might get into these things as I start building examples and have to make those decisions, but right now I'm just looking at how you put it together. Okay, so this is going to be the layers tutorial part 1. I'm going to do a second part to this because all I've done right now is I have created the model. And I have compiled it. The 2 things that I need to do with this is I need to send data through it. I want to put data through it and look at the outputs. What are the things I might want to do? The 2 things I might want to do is use predict. Predict is a function where I give the model inputs and I get out of predict the outputs. Presumably I would only be doing predict after I've trained the model. So I'd want to train the model with some training data. It's finished, then I can make predictions with new unknown data. So how do I train the model? I use a function called fit. Fit is a function that I can, basically I'm saying I want to fit, just like we had to, in the linear regression example, I had a lot of points, and I had to find the line that fits those points. I need to find all of the weights of this machine learning neural network model that fit the data. And guess what? This is what TensorFlow.js is going to do behind the scenes. It's going to do all of the stochastic gradient descent math. It's going to use its own loss function, everything underneath the hood. So all the stuff I did in that build a neural network from scratch now is now done for us by TensorFlow.js, and it has many more sophisticated options. So that's what's coming in the next video, looking at fit and predict. Okay, thanks. Okay. All right, how are we doing now? It is 4:30. Oh boy, so I'm a little bit, I'm a half an hour over time. If you will just humor me for a second, I have got to send some messages to make sure everything, okay. Great, I am live streaming, will be done in an hour. Okay. I'm looking at my email. I should be looking at my email. Okay. So I definitely want to try to do the fit and predict. So I'm weirdly going to do predict. I assume I could use predict even before I do fit, which is silly, but just to see it give me something. Okay. All right. Thank you, Carson, in the chat. Always nice to hear positive feedback. I really started off, was rough today at the start. My melon is all gone. I'm out of my caffeinated beverage. Am I? Maybe there's some more in here. Oh, there's plenty more in there. Oh, good. This might be what I need. Okay. All right. All right, let me check the Slack channel. And let's go, let's move on. Ah! Let's move on. All right. It's very loud in the hallway. Can you hear that? Oh my goodness. I guess no one's complained about the sound. Yeah, so I think some people are maybe watching for the first time. What you're watching is almost my like tutorial recording sessions. There's a lot of live, and so there are two ways you'll be able to watch this later. One is as soon as I finish, this will get archived online, the full, what is now 2.5 hour long, maybe possibly 3 hour live stream. And then within a week or so, edited versions of these different pieces and tutorials will come out. Add some comments to your code. That is a very good idea, Chris Ray. All right, let's do that. That's what I'm going to do at the beginning. All right, welcome to TensorFlow.js, the Layers API tutorial part 2. So previously on TensorFlow.js, the Layers API part 1, I created this model using tf.sequential, tf.layers, and model.compile with a loss function and an optimizer. Now, let's just review that really quickly before I go on to the next step, which is looking at fit and predict. So I'm going to add some comments. Thank you to the chat just suggested that. So this is the model. Create the hidden layer. Add the layer. And the hidden layer has number of nodes, input shape, and an activation function, which I think is probably pretty self-explanatory. Then the output layer, and it's a dense layer. So dense is a fully connected layer. Then create an output layer, create another layer, and here, I'm going to write here, the input shape is inferred from the previous layer. Then an optimizer using gradient descent. I must have a video somewhere that talks about what gradient descent is, if that's not familiar to you. And then I'm done configuring the model. So compile it. I don't know if this tutorial should have included me writing all these comments, but it did. So that's where we are. So in a sort of standard or sort of classic machine learning process, I would configure my model. And actually, before I do any of this, I should have collected my data and been really thoughtful about that and thought about the ethics of it and why am I doing this in the first place? And is this going to help people or hurt people? I should have been doing all of that. But here I'm just looking at TensorFlow.js as an API, so I'm kind of skipping those really fundamental, the most important parts. I'm doing things backwards in a way. And I'm just going to make up data. So what I want to do is there's two things. One is I want to train the model. I want it to adjust all of its weights to fit my training data. I have these inputs with these known outputs. Maybe I'm doing image classification. I have all these labeled images, cats, dogs, turtles. And I want the model to output cats, dogs, or turtles, some probability values based on which things it thinks it are. And then, so that's what this fit function does. I can also ask it to do predict, which means just take this data. I don't know what it is. This is not part of my training data. And just give me the output. So let's do something weird. I mean, weirder than what I'm already doing, which is talking to myself in a room with a camera and some lights. I have an iPad with weird, stupid sound effects on it. I don't know what's happened to me in my life. Anyway, let's run predict without having trained the model. Will it actually just, what does it start with? It must have a whole bunch of randomly configured weights, right? It must be configure itself randomly. Let's see if we can get some output. So what do I need to do to call predict? Let's go look at the API. And let's look at, I'm looking at tf sequential. Sorry, I'm not in the right place. Hold on. Let's start this over. Let me get it. Sequential. Okay. Let's go look at the API. And let's look at, again, tf sequential. So I'm looking for the predict function. Now here's the thing. The predict function is there. So it generates output predictions for the input samples. Model.predict. Okay. So config, there are some configuration options, like batch size and how verbose I want it to be. But really all I need are the x's. The x's are the inputs. And I need two of them. So what I'm going to do is I'm going to create a tensor. I am going to say, let input, or I'm going to say const inputs equals tf tensor 1d. And let's just give it some numbers like 0.5, 0.25, 0.25, 0.93. So 92. So I just made up some inputs. These are all fake, not real data at all. I'm just trying to look at how TensorFlow.js, the Layers API, works. So now I should be able to say model.predict inputs. Now let's go back and look at this. Model.predict tf1s. Oh, interesting. Nope. I guess I'm good. Okay, so hold on. So let's say let outputs equal model.predict inputs and outputs.print. I don't know. Could it really be as simple as that? Let's see. And so now, I'm going to go back here. Uncaught. Expected dense input to have 2 dimensions, but got array with shape 2. Oh boy, I think I might have a big major mistake here. Let's think about this. The input shape. I have to think about this. Dimensions of inputs should match. What did I? Good timing for the cameras to go off. What have I done wrong here? Is it, oh, it has to be this? No. Because the first dimension is the batch dimension. So that worked. So then I don't have to say this then? The shape is supposed to be 2D. It should be 2, 1. No. Oh. So it's... Okay. Because in theory, yeah, I see. Okay, okay, I got it. You go back to this error. Interesting. Yeah, wow, this is tricky. Okay. Yeah, that's totally true. Okay, sorry. All right. Huh, I got an error here. That's weird, right? This is actually this is the kind of error you're going to live with if you continue down this road a lot, which is like requires shape, blah, 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 shape. Oh, wait, no, hold on. Sorry, that's not the right error. Ah, okay. All right, so what is this error? Oh boy, this is the kind of error you're going to get a lot, which is something is wrong with my like shape. Shape errors, error when checking, expected dense1 input to have 2 dimensions, but got array with shape 2. What is wrong here? I mean, after all, there are just 2 inputs. I said very specifically that the input shape is 1-dimensional with 2 things in it. So why is this wrong? Well, it turns out I forgot about this idea of batching. So it is quite uncommon, or it is possible that you just want to send in a single data point, like these 2 numbers in and get the prediction. And so even though this is the array of the inputs, that needs to live in an array itself because I might want to send in multiple sets of them. And so actually the correct way for me to put this here is to actually have this be the first element in an array. And actually this is not a 1D tensor then, it's a 2D tensor. So now if I run this, we should see, there we go, these are the outputs. And we can see here, every time I run it, I'm going to get different outputs because this particular model is initialized randomly. Now there's probably a way with the Layers API that I could configure how the weights are initialized, but it's using some default, probably random, maybe it's a normalized distribution of random numbers, who knows? We could look up in the documentation, somebody in the comments will tell me. Okay, so, but what's interesting about this is now, right, I could have, right, I could now send in 4 inputs, and what will I get out? All of those results. So these are the 3 output values for the first input, the second input, the third, the fourth. So this is how the predict function works. So I can create a model and I can start predictions. Now, they're useless and pointless and random without me actually training that model. So that's what I need to do next. Fit. There were some other things I wanted to say about this. Should I have said 1, 2? No. 2, 1? No, I'm... Try input shapes 8. Oh, is the live closed captioning on? I was hoping I would get that feature unlocked for my channel. Could somebody send me a screenshot of that? I'm just curious because I guess I could look at it myself. But I would love to see how that works. Or like a GIF or like a quick... Oh, great. Herman in the chat is looking up... All right. So I'm going to move on to fit. I see that K Weekmine is typing, though. So I'm just going to, if you have a 2D input shape, you need a 3D tensor for, yeah. For predict. So it's always one for predict and fit. Okay. Okay, so let's now create a scenario where we have some training data, right? This is my, and by the way, there is this really important piece of working with machine learning where you have both training data, testing data, you can even have something called validation data, and then you have the new data, the stuff that you're making guesses and predictions with. So I'm not getting that far into it yet, but let's just, in this case, I'm just gonna have some training data, I'm not gonna have any testing data, although we'll see. I mean, we're going to look at fit. We're going to see how this all works. So let me go back now to the I'm looking for where I was. Predict, fit. Here we go. So now I want to look at fit. So here, oh, look at this. Await. I just made some video tutorials about await. So one of the reasons why, so working with TensorFlow.js natively, you're going to feel somewhat comfortable with the idea of a JavaScript promise and these new ES8 keywords, await and async. So I'm going to use those concepts. You might want to check my promises playlist if that's new to you. Okay, so let's figure out how we're going to do this. So model.fit. The parameters are x's, x and y. So here's the thing. Unlike here, and I really should call these x's, and this is really the y's, right? This is really what I'm doing. These are the x's, and now I'm getting the y's. To fit, I want to do the same thing. The difference is I'm going to have some known outputs. So in this case, I might have, like, this is my training data. These are the x's, and now the y's are I need to make, presumably this would come from a spreadsheet or some type of actual database that I've thoughtfully thought about how to collect and the data and what I'm doing with it. But right now I'm just making up dummy data. So each one of these, I probably should just put in random numbers. But I'm like weirdly sort of lazy about this. I like you to sort of see it. So let's just pretend my training data set just has, instead of 4, let's just have 3 things in it. And let's just make some arbitrary. Okay, so this is now my training data. I have the x's, right? The x's are, there are only 2 of them. Again, if I were doing my image classification example that I did previously with the toy neural network library, I might have 784 inputs for 784 pixels. But here in my made-up scenario, there's 2 inputs and there's 3 outputs. So the x's have 2 and the y's have 3. And you can see that reflected here. So now I should be saying model.fit the x's and the y's. Let's look here. Now, here's the thing. There's this variable called history. That's kind of interesting. So let's say const history equals model.fit. And I got to get into the await and all that in a second. So what the history is that's an object that's returned that has lots of information about how the training is going. Like how accurate are things? What happened there? If I want to start looking at the properties of the training, what's the current loss? That type of thing. Oh, right, these mismatch. Thank you. So I was trying to simplify 3 and 3. These have to match. Thank you to the chat for mentioning that to me. Okay. So then I have this idea of batch size. So batch size is, let's look at that, number of samples per gradient update. If unspecified, it will default to 32. So this has to do with the inner workings of how the gradient descent algorithm works, right? At some point, gradient descent is going to look at the error and is going to make all these adjustments to the weights. And so does it do that? Does it do that after 10 data points, after 20, after 32? So I'm going to ignore that. And then epochs or epochs, or I could never know how to know how to pronounce that word, is the number of times to iterate over the training data arrays. It's optional. I think the default is 1. So here's the thing. I'm actually just going to let this go without setting any of those. Those things are going to be certainly important, hopefully as I get into future examples or as you have specific scenarios. But basically, I could add an object here that has things like, that has various configuration properties, and this would need to be a comma here. But I'm going to skip that right now because I believe, according to the documentation, config is completely optional. So let's just run this, and then I'm going to have to start talking about the asynchronous nature of this. All right. What happens if I say console.log history? Let's just look at that. So look at that. I got a promise. Oh, it's promising me something. So what this means is fit is a function that executes asynchronously. Now it's possible I can do things with a kind of older style of JavaScript using callbacks, because it looks like in the documentation here, one of the options I can specify is a callback, but I'm going to use promises. So what I'm going to do is I'm going to say model.fit, then, and what I want to look at is, I don't know what, I'm going to just sort of see. And in this case, I think actually, the way that I'm doing it, I'm going to look at what's sent into the promise. So this should be a way, if it returns a promise, I can figure out, I can get the result of what it's done as an argument to a function that's executed when the promise is resolved. So this is how this could look, just to look at that history. And you'll want to look at my promises videos if this syntax doesn't make sense to you. And we can see here, looks like, oh, I have a history object and I have a loss. There we go. So this is actually the response. And what I want to look at is the response.history .loss index 0. So looking at this, there we go. Now what happens if I give it a lot of, now what happens if I start to add in a configuration? Like, because I'm really curious, what happens if I say, so let me actually use a variable, I'm just going to call it config. And I'm going to say, two things I want to add is I want to say verbose is true, and I want to say epochs is 5. So because I want to see if it's verbose, am I going to get a lot of stuff in the console that's going to tell me about what's going on. So I want to add in some of those parameters. Verbose mode is not implemented yet. Oh, okay. So I guess I can't use verbose mode, but I can add 5. And so this is just the loss after 5. Let's add 100. 0.2, negative 0.2. So you can see it's pretty consistent. I'm kind of getting about the same. I mean, it's sort of an arbitrary data. All right. Pause. I lost the chat. I'm sorry, I'm looking at the chat, see if I missed anything super important. Epochs. Epochs? That's how I like to say it. Okay. All right, so if I put this in a loop, so let me ask a question to the chat. What I want to do is put this in a loop and show the loss changing over time. And so, oh, I have a trailing comma. Oh, yeah. Yeah. I'll fix that in a second. Yeah, right? Why is it negative? Oh, I'm in cosine distance. All right. All right, actually, something weird was bothering me there for a second, which is why do I have a negative loss? Like, you can't have a negative mean squared error, right? Mean squared error has to be positive. It's the difference squared averaged over all the data points. So I forgot that I still had cosine distance. So let me put it back to mean squared error. And now we can see that I'm getting something that looks like it could be mean squared error, yes. So one thing about this, okay, so I'm going to get rid of this config. Actually, Mathieu, let's try to go back to when I first run this code. Oh. No, it's fine. It's fine, let's leave it. All right, I'm going to get rid of this config. Whoops. I'm going to get rid of this config because what I want to do is I want to look at what if I want to like what do I want to sort of like watch the loss over time? And I'm trying to think about the best way to do that. But what I think I'm going to do is I'm going to write a function myself called train, and I'm going to put this, and I'm going to say const history equals model.fit, and then I'm going to add await, and I'm going to say async. So by the way, if I want to, so even though I was using a promise here, this is a way that I can put model.fit in an async function that I define myself to sort of clean up the syntax a little bit. And then I can say return history. I guess this is silly. Is this silly? But because what I want to do is I want to call train recursively, I think. So I want to say train. Then, yes, this is exactly what I want to do. So I need to just not use the arrow syntax for a second to just sort of figure this out. So I want to say train, then once I'm done training, execute this function that gets the history. I want to say console.log history.lossIndex0. And then I want to call train again. Oh, no. And then I want to say, yeah. Then I want to say return, train. Oh, I'm lost here. How do I do this recursively within a promise? This is an interesting problem. Do you see what I'm trying to do? When it's done, I want to, and I'm going to just add the arrow syntax here now. I want to kind of like run train again. I could just say then, Pause for a second. K. Weekman is pointing me to an example of model.fit. Oh, look at this. Oh, of course. Of course. What am I doing? The reason why I want to move into an async function is now I can actually put a loop in here. So this, right, the fact that I'm using await means I can actually put this here. I don't need to return anything, right? This now, what I can do here is I can say, I can actually just call train. Like I don't need anything to happen, but I'm going to say train.then. I think I want to go back, hold on. I have to figure this, I'm torn whether the whole figuring it out is like super useful or it actually makes more sense for me to like just go back and do this again because it's sort of a mess to edit. Yeah, a loop instead of recursion. The recursion idea was like, let me go back. Okay, I'm going to go all the way back. To before I added the async function. And I'm going to go, OK. So now I have loss values that make more sense. Here's the thing, though. What I want to do is I want to do this a bunch of times. Like, there's going to be a lot of scenarios where I want to animate something as it's training. I want to graph the loss function over time. So how do I do this multiple times? Well, I want to have a loop, right? I want to be able to say for, I mean, I could have multiple epochs. So I could like add the configuration that gives me multiple epochs. Oh, do I need to go? But that I had before, sorry. But what I really want to do is this. I want to just do one epoch at a time. So this should weirdly work with like a loop. It's really awkward the way that I wrote this. I feel like, hold on, sorry, did I delete something back here? Yeah. Like, let me just run this for a second. Oh, I'm missing another parentheses here. Sorry about this, everybody. This tutorial is a mess. 48. Oh, I had him there already. Ah, zoomed in. Wait, hold on a second. Let me try this again. Just one more time. Yeah, that's right. Model.fit. Why? This is where my brain starts to die. Yeah, there should be another parentheses here. There we go. Okay. Let me go back to the chat. All right, so now I'm getting loss values that make more sense. But what I really want to do is I want to see the loss values over time. Like as I'm fitting the model, I'm running the training data in multiple times. Maybe I'm shuffling the order. There's all sorts of things that I've done in previous videos that I want to do with TensorFlow.js. So how do I have this model.fit multiple times? I mean, I could just call it twice, right? Ooh, it did not like that. Whoa. Oh, fascinating. So I can't do that. I don't know what's wrong with that, but that's not really what I want to do anyway. I could try to add a loop. By the way, the chat is really upset that I have these extra commas here, so I'm going to remove them. JavaScript doesn't care. It's like, put your commas wherever you want. Like, add a lot of commas, right? Oh, no. It doesn't want extra commas because it has blank entries. But OK, so what if I were to put a loop here? Say like, oh, I want to do this 2 times. So I want to fit the model twice. Again, I got an error. Ooh, it really doesn't like this. So here's the thing. I'm not exactly sure what this error is, but maybe somebody will tell me in the comments. But I was going down a road I didn't want to go down. This is where using, wherever it was here in the TensorFlow.js, the await keyword is crucial. So what I want to be able to do is I want to be able to call this fit inside a loop, but promises, just like everything's happening asynchronously, it becomes very hard to follow. So actually, what I really want to do is I want to go back to that syntax of saying const history equals model.fit. And then this is what I want to do. I want to say then console.log history loss. Okay? This is what I want. This is like synchronous code, blocking code. This is what I want. I want to fit the model and then see the results. It won't do this because that's not how JavaScript works. It works asynchronously. So there is the await keyword, which is new in ES8, which says, hey, wait for this, and then do the next line of code, right? Shouldn't that work? Whoops. And await is only valid in an async function. So again, if you watched my async and await tutorials, you would know this, but I cannot just do this anywhere in my code. I have to create a function with the keyword async. I'm going to call it train. And I have to do this inside that. So this is now the correct syntax. This actually is valid, but it's in an asynchronous function. I have to call that function. So I could just call train. Let's just run this now. And, ooh, cannot read property 0 of undefined in train. So what do I have wrong? Let's put the x's and y's in that function. Oh, that's not the problem. History. Oh, hold on. Let's just look at the history. Oh yeah, it's there. History. Oh, dot history. Right. I keep forgetting. This is the response. So it was fine actually. History dot loss index 0. So I just want to look at just the loss. So these don't need to be in here. I don't want these in here. So now we run this again. There's the loss. Now, here's the thing. I'm just going to put a then in here because I also want to have some sort of event for when the training is complete. So this function now kind of magically returns a promise because of the way that await and async work. So I want to make sure this is working. Great. And now training is complete. Now guess what? I can now do this. I can do this 10 times. So I can now, the loop can go in here because of the beauty of this await syntax. This is now work functions as if it's blocking code. When it's all complete, it will return a promise. There we go. And we can see this is what we should have. The loss should be going down, right? Let's change that learning rate. Somewhere I set up a learning rate. Let's make the learning rate 0.5. You can see the loss is going down. And maybe, let's go back to 0.1. Let's give it like 1,000, basically 1,000 iterations. And we can see the loss is going down over time. So, and now what I could do, 1,000 is a lot. The training is now complete. Now what I could do is I can call, remember this, I can now call predict. Now again, I'm only working with one data set. My training data is my testing data, is my validation data, is my regular data that I'm using in the future once I'm done training the model. So, but we now see the full process. I have x's and y's. I can call model.fit. And again, this is really hairy stuff, not for the faint of heart. I'm in the weeds of the sort of like lower level TensorFlow.js stuff. Even though I'm in the Layers API, but using ES8 syntax. But now we should be able to see. Let's take a look at, I'm going to have an issue here where I have these y's. So I'm going to call this outputs. So let's take a look. Let's train it just 100 times. Whoops. Oh, whoa. Silly me. Look what happened. So I totally forgot about the asynchronous nature of all this stuff. And I got the predictions before the training finished, right? Because this is happening asynchronously, which means what I want to do is after the training is complete, then I want to do my prediction. So I want to train using the asynchronous training 100 times. Then I want to do my prediction. Train, the coding train. And then let's look at this. So how do these numbers match with what I said the outputs should be? Not so great. Not so great, huh? But, I did my best. Maybe, oops. But really, the issue here is simply that I'm working with such like fake, pretend, small, arbitrary data that I can't really do any training and inference here in any meaningful way. By the way, inference is another word for what's happening here with this predict function. But I'm hoping, I just want to, while I'm talking, I'll let this run one more time with like, let's try 3,000 training it, and let's actually, let's try it with 3,000. So I'm going to let the loss function go down. Much further. So okay, so hopefully now you've seen, right? The first, Well, I can't refresh the page until it's finished. So while this is training, hopefully now you've seen here that I have now in these 2 tutorials covered the basics, just the basics of the Layers API. The Layers API, you can create a model or a TF sequential or tf.model that has some amount of layers. They can be dense layers or other kinds of layers I haven't explored yet. I can configure those layers, I can add them, I can compile the model. And once that's done, if I have data, I can fit the model with that data, and then I can ask for predictions with new data. And this is what I'm hoping to do. So I've got to come up with some actual real-world scenarios. And the first thing I'm going to do as a coding challenge, which basically redo all this again, is I'm going to try to just do the XOR problem. So I have an XOR coding challenge already, and I'm going to do that. So that video will be out at some point in the future or right now, depending on when you're watching this. Let's go back and check. So the loss got all the way down to 0.5, and we can see the outputs here. 0.23. The outputs are very similar for each input. So I'm just going to assume that the problem I'm having is just the fact that I have just this tiny little bit of data, and I also trained it for a very, very little bit of time. And I might not, but actually I want to look for the shuffle option. Before I go, something that's really important, I don't know if it's doing it by default. When you are, in this fit, there is an option called shuffle. Whether to shuffle the training data has no effect, optional. So the question is the training data shuffled by default? When you're training with the same data over and over again, if you keep the data in the same order, that can really be problematic in terms of how things work, how well it performs. So I want to add that. So where do I add that? That's important. So right here, I'm going to add shuffle true. So it's basically just a parameter, just one field of this configuration object where I want to say shuffle is true. And let's just do it 1,000 times and go back. And let's see if I get that loss much further down. Yeah, not really. I'm going to do one more thing, which is I'm going to add epochs 100. So each time through this, I'm going to do it 100 times, and then I'm going to do that 100 times. So that should give me 10,000 times, just to get it going further. Yeah. I think this is a fool's errand. I'm never going to get this to produce overfit. I want it to overfit my data. So Matthew, we're going to get rid of all this stuff from the end here. As if I'm, all right. Ooh. Okay. Yeah, that's like kind of 0.4, 0.3, 0.4. Can't remember what I said it was. Yeah, I mean, how could you, this makes no sense. Okay. My data makes no sense. So this ended, and you can see this is a fool's, I'm on a fool's errand here. It makes no sense. I got these like little 3 data points with 2 numbers in them, and I'm trying to get 3 numbers out of each of those and train the model, and then this is never going to go anywhere. So I'm going to do this again in the XOR example. I do have one more idea, just to make it, I wanted to get a result that makes sense. I have one more idea. Just give me a second here. Let's just change this model to have the output just have one output. And so now the y's, like I'm going to say 0.1, 0.1, I want that to give me like 0.9. And then I want to say like 0.9, 0.9. I want that to give me 0.1. And then I'm going to say like 0.5, 0.5, give me 0.5. So this is now going to be my data, much simpler. Like it has like a very simple linear relationship. So I think that I should be able to now. I'm going to go back to 1 epoch. I'm going to do this just 200 times. And we're going to now fit this model. And here we go. Oh, I really got to, let's increase the learning rate. Oh, man. Let's increase the learning rate. Let's do it 1,000 times, 10 epochs each. All right, I'll be back in a little bit. Oh, look at this. Look at that loss. I finally got somewhere. See, this is the machine learning is hard, all these parameters and what you're doing, but this is going to end in a second. I'll be back. This can be sped up. This can be sped up as it's training over and over again. This is so silly. I don't need to watch this for the whole time. By the way, I'm going to be going. I'm not going to do the XOR thing today because it's already 5:20 and I'm late. Anybody have any idea where I am in the number of, like, what would you estimate now? How long is it going to take me to get to, there we go. Yay, look, I made it do something. I made it match the exact, I overfitted my model basically, but I made it match the exact output. So my issues were really learning rate and the amount of time I gave it to train and that sort of stuff. So hopefully now, I'm really at the end of this video. Apologies that this was maybe a bit convoluted in terms of how it came together, if it came together at all. But now I've really completed my 2 tutorials on the Layers API, and in the next video, I will do some coding challenges and actually use the Layers API for some, hopefully some more practical examples. All right, see you later, goodbye. Yeah. Carson is giving me some good feedback. I mean, I have like, I'm going to go back to I'm going to do this whole last section again, just in case. So let me go back. Just because there's a lot of mess there. And I don't mind doing this stuff twice. So at some point, oh, right. I'm going to go I'm going to go from here. Okay. All right, Mathieu. What I'm going to do now is if we go all the way back to basically the first time I ran it, putting predict inside of here. Okay, so I didn't, way back. So I'm going to do that. Okay. All right, here we go. All right, so this is running. We can see that the loss is going down. It's training over time. And when it gets to the end, I've got the results of my predictions. Now, you can see these don't look very good. Like, first of all, these don't resemble these outputs at all. The main issue here is that nothing here makes sense. I just have the skeleton of the story of data. I can create the model, I can fit it with some data, and I can ask it to run a prediction with that same data. But I'm ignoring like really important considerations, and you can see that machine learning is just magic. It doesn't just do the right, I don't get the right answer. So let me at least, before I go, add a couple things so that we can actually see that it got somewhere. So one thing that I want to do is I'm going to just simplify what's going on here. I'm going to make this data something really obvious, like 0, 0, 1, 1, 0.5, 0.5. That's my x's. And then my y's, I want to get 1. I'm going to just change that to just one output, 0.5 and 0. Whoops. What did I miss here? Yeah. Oh boy. Syntax, there we go. So what I'm doing here is I'm just trying to like come up with some ridiculous scheme that's like super simple to learn. Like there's sort of like an inverse linear relationship here. 0 goes to 1, it's like the map. Basically, let's see if this neural network can learn the map function. But I don't know why I'm using 2 numbers and 1 numbers here, but whatever. So now I am going to, I have to change the output to have just one output. And now let me run this. So we can see, look at this, the loss function is still pretty high. So there is something that's kind of important here. You can see it's going down, and actually after like 1,000 iterations, it kind of got something pretty close. So I would just need to give it more time to train to kind of reproduce the known results. But I just want to show a couple important things here. One thing that's important is I should always shuffle the training data. So there is actually a kind of important, one of the configuration parameters here for the fit function, like if I shuffle is true, what this will do is whatever the x's and y's are, each time it puts it through the training function, it'll do it in a different order. And this will really help things as you're training with the same data over and over and over again. So let me add that in and just see what happens there. So I'm going to add this config here to here. So this is shuffle true. This is the only thing I've turned on. I'm doing one epoch at a time still. So let's also, while I'm here, just to make things go a little faster, let's do like 10 epochs at a time. Once again, total here, 1,000 times 10 is 10,000 epochs, right? But because I want to see it over time, I'm not just doing this once with the number 10,000 there. I'm doing it 1,000 times with 10. But this I think will make things move a little faster. And we can see I got even better here. And so now we can see this over time. We can see that the loss is really going quite far down. Now I'm going to have to sit here and wait for a minute, which I'm going to do, but you're not going to have to. This video will now speed up. Funniest discussion is going on in the chat right now. I'm going to check my email while this is going. Thank you, Grant Rosmarin, for sponsoring my channel. All right, I'm back. So look at this. I reproduced those results, right? I reproduced the same results that my training data should have produced, and I got the loss down pretty low. So you can, again, completely meaningless, trivial nonsense, nothing, but hopefully this is helpful to you. It's helpful to me because I'm trying to figure out just how the library actually works itself. So let's review for a second. Okay, let's review everything. I have shown you now in these two videos that I can create an empty model, right? The diagram of my neural network architecture is an empty model. Then what I can do is I can create layers. There can be dense layers or other kinds of layers that I might look at in another time in the future, and I can add them. The order that I add them is very important because it is a feed-forward sequential model. So this is first and this is second. These, I'm thinking of this as hidden and output, but they're really just layer 1, layer 2. Okay. Once I've done that, I have to define what sort of mathematics are going to be used to train the model. And there's a loss function, mean squared error is what I'm choosing to use, and an optimization function, stochastic gradient descent, with a learning rate of 0.1. That's everything from part 1. And now what I've done here is I've shown you, okay, if I have some data, presumably coming in from a spreadsheet, I turn those into tensors, I can use the fit function to train the model. I can say fit all of the weights with these x's and these y's. Once that's complete, I can then ask it to predict with presumably new data. This skeleton has not used any meaningful data. I'm also not really being thoughtful about what activation function makes sense or what optimization function makes sense. Different things work for different scenarios. So hopefully we'll see that more in the future as I make more videos. I would encourage you to just try to do this maybe with some actual data, play around with it, try different input shapes, activation functions, play around with it a little bit, see what you get. Let me know about those results in the comments. Let me know if this was helpful to you, and I will see you next video. I'm going to look at that XOR problem again in the context of TensorFlow.js. Okay? Goodbye. All right, everybody. I don't know. Mathieu, if you're still watching, thank you, John. You only look once. If you were still watching this, Mathieu, hopefully this can be put together. And the fact that I did that section and twice. One thing I'm a little worried I did is I kind of recapped twice, so you could cut out my earlier recap. But you always seem to figure this out. So, but if this is really problematic, this last section, I can always do that again. All right, everybody. Unfortunately, because I have to go home, I don't have time. Maybe I could bring the stuff home with me. I don't have time to live stream my experiments with these lights. I'm so brain dead right now. So yeah. Sarah in the patron group in the Slack asks, who is Mathieu? Mathieu is math blank. Mathieu is the coding train. I don't know what his title should be, but video editor, coding train, channel organizer, manager extraordinaire. Oh, the sound effect was glitching. The sound effects are glitching again? Tell me if they are. Sorry, this might hurt your ears. Turn your volume down. 3, 2, 1. So, yeah. Is that going to be a problem? Why does that happen after like a while? I think it has to do with where these cables are. It sounded kind of fine now. All right. nothing changes at all except you have consistent commas at the end. Oh, shoot. That's going to drive people crazy. Yes, choppy. I'm so confused by all the chat stuff that's going on. You know what? Sometimes the glitching is actually just in the live stream, and the video that I'm recording might not have the glitching. That might be wishful thinking, but that's happened before. That's probably wishful thinking, because hold on, it's gonna glitch again, okay? But I'm gonna listen to my monitor. 3, 2, 1. Oh boy, I'm really loud. I'm listening. Oh wow. 3, 2, 1. Yeah, so I'm just gonna, at the moment, hope that the glitching is not in the recorded video, so when this gets edited. All right, I have to go. There's so much activity going on in all these different chats, I can't keep track of anything. I'm completely brain dead. This has somehow been like a 4-hour live stream. So you know how I said I was gonna do 2 live streams a week? I was doing that because I wanted to do 2 hours at a time twice instead of 4 hours, because everything goes, you know, I really like, this is, I didn't do a good job of like, this is how I feel right now. But this was 2 live streams this week because I did it for like 4 hours. I will see you all next week. Probably Friday. Not Tuesday. Possibly Wednesday, not Thursday, possibly Friday. So yeah. Okay, I gotta go. I'm gonna play the outro and see you all. Usually I try to answer some questions and stuff like that, but it's already 5:30. I just can't. I will train. I wish I had the ukulele so I could sing you out. But I will blow the train whistle. Still waiting for the water ripples in tf.js. I don't know, that may never happen at this point. But if people are really interested in that, I will come back and do that. I mean, maybe I'll do that when I get to like convolutional neural networks.
Let's find something we want to make, some crazy idea. We'll figure out what it takes to make that dream appear. We'll try to understand now as we ride along again. Now hop on the coding train, coding train, coding train. Come along and join us as we light it up in code, using only our imagination.